Good evening, dear students. Hope you all might have joined. Yeah, welcome to this paper discussion of this engineering services prelims, which happened today. I hope that you all might have done well. Coming to the paper difficulty level, it was a bit difficult compared to last year, and almost in all the subjects, as we say that questions are mostly on the theory side compared to the numerical. So that's what the unpredictability of the engineering services, which is highly unpredictable. Most of the times it used to be numerical, most of the subjects, but this time it seems like they are more inclined towards the theory compared to the numerical. Particularly when it comes to control system, as you can see, there were 10 to 11 questions, and hardly 2 of them are numerical, 2 or 3, and remaining all are theory questions. So this time the trend has been towards theory compared to numerical, but a bit on the tougher side compared to last year. So I'm going to make control system discussion, control system paper. Starting with this, the question is about finding the DC gain. A second, please. Right. Sorry for the interruption. I think we are back. Sorry for the interruption. The question is about the DC gain of the system. You see that the transfer function is given. DC gain we can find by substituting S is equals to 0. That comes out to be 2 upon 1 into 3 into 4. That becomes 1 by 6, which is option A. Answer to this question is option A. In this question, we are asked to match the following, but there is one big problem here. See, basically, impulse signal is used for the transient response analysis. Impulse response is transient response, so that can be matched with this. Then, this parabolic signal, it is exclusively used for the steady state error analysis. These two options are matching. Parabolic signal, we use it, ramp and parabola, we use it exclusively for the steady state error analysis. Impulse exclusive for the transient analysis. Now, when it comes to this step and sinusoidal, they are used both for the transient analysis, but sinusoidal signal cannot be used for the steady state analysis because of its periodic signal, final value theorem not applicable. But the remaining two options that we are left with, they both have steady state error in them. So it's really not possible to match this thing. So I am saying that this question is not properly framed. Sign can be used for transient analysis, step can be used for transient analysis. Transient analysis and steady state error, so that will not match for the sinusoidal signal. So according to me, no proper answer for this. In this question, we are given with a state model and we have to find the transfer function. Most of the students, they try to use the shortcut that we used to discuss in the class, that use the coefficients in the row of row array to frame the denominator polynomial. That won't work here. I told you that is only for the structure 0, 1, 0, 0, 0, 1, and then the coefficients can be used to frame the characteristic equation. So most of the students, in hurry, if you think like this, then you will go wrong. They think that the coefficients have to be 1, 2, 3 from right to left. So 1, 2, 1, 2, 3. I think you might have chosen option A, but that trick won't work here because of the structure which is not applicable here. You have to use this formula, P into SI minus A inverse into B plus D. This is the formula to find the transfer function. So which when you use, it is going to be option B to this question after solving all duty. In this question, It is related to the first order system. Statement 1, time constant of the system can be described as the time for the e to the power minus at, which happens to be the impulse response of the first order system, basically to decay to 63% of the initial value. Yeah. So initially, whatever transients we have got, 63% of that it has to decay, right? It has to decay to 63% of its initial value. But that's the false statement. It has to decay to 37% of the initial value. Time constant is defined as the time required for the 63% transients to die out. It means it has to decay to 37%. It means 63% is the last. Even if you don't understand that one, the second one is very clear to say that it is a false statement, or it is the time taken for the step response to rise to 37% of its final value. When it comes to step response, it is the time required to rise to 63% of its final value, right? So this statement is false. Second, rise time it find to be the time for the response to go from 0.1 to 0.9 of the initial of the final value. That's true for first order system. Settling time is defined as the time for the response to reach and stay within a specific tolerance band. 2% we take it by default to solve the numerics if not mentioned in the question statement. So most of the people, they think that steady state error is the time required for the step response to reach and stay within 2% of the tolerance band. That's false. 2% we take it by default to solve the numerics if not mentioned in the question. So settling time is a time taken to reach and stay within a specific tolerance band. And that specific tolerance band is defined by the user or given by the examiner in the question. Maybe 1%, 2%, 3%, 4%, 5%, 6%, 7%. It can be anything. So it is true. Question is, which of the following statements are true? Okay. Which are not correct? That means false statement. So false is only one only. Question is about false. 1 is false, 2 and 3 are true. So answer is 1. This is about second order system. Peak time is inversely proportional to. The peak time formula is pi by omega d. Second order system complex roots are minus alpha plus or minus j omega d. Imaginary part is omega d. So peak time is inversely proportional to the imaginary part of the complex poles is a true statement. Yeah, good evening. Evening is not good. Paper is overloaded. Yeah. Because see, the overloading of the paper is because of this vast number of theory questions. You feel delighted and you feel that the paper is less loaded if you have got numerics. Usually numerics in engineering services will be easy, right, on the easier side. But when it is majority of the theory questions, then obviously see you have to reach each and every statement and you have to understand the language of the question, the terminology used, and it sometimes it confuses. You have to read each statement twice and thrice to understand the loopholes involved in that, and then you have to come to the answer. So it's really not that easy. That's why students feel it to be overloaded. Really correct. Yeah. Second statement, percentage overload should be overshoot. It has to be is a function of only damping ratio. Overload, overshoot. MP is only depending on zeta from its formula. That's a true statement. Third, settling time is directly proportional to the real part of the complex poles. Settling time formula for 2% tolerance 4 by alpha, it is inversely proportional. So this is false. Question is about which of the following statements are true? 1 and 2. Option C. 1 and 2 only. For the closed loop transfer function below, what is the system condition based on the number of poles in the left half and right side of S plane? If you solve this route array, s to the power 4, s cube, s square, s power 1 to the power 0, 1, 6, 11, 6, 200, 66 minus 6, 60 by 6, 10, 200. This is 60, this is negative, this is 200. There are two sign changes. So 2 in the left side, 2 in the right side. Answer is option B. The system is unstable since it has two right hand side poles because of two sign changes. The remaining 2 will be in the left side because no row is 0. Consider the statements regarding stability of linear time invariant system. using natural response. Using natural response, which of the following statements are true about the stability of linear time invariant system? What is the important statement? The system is marginally stable if the natural response is neither decaying nor growing but remains constant or oscillatory. Yeah. So marginally stable kab hoga? When the natural response is neither going to die out nor it is going to tend to infinity as time tend to infinity. So it may remain to be a constant value, or it may be oscillating in a constant envelope like the sinusoidal signal. That's a true statement. Second, a system is unstable if the natural response approaches to infinity as time approaches to zero. See, as time approaches to zero, then the value of the natural response is considered to be the initial condition of the system. Value of the natural response at t is equals to 0, that will be the initial condition. And initial condition is supposed to be 0 for LTI system. LTI system के लिए initial condition 0 होता है ना, क्योंकि linear system is that whose output depends only on the input presently given to the system. तो इनिशियल कंडीशन इन्फिनिटी की बात कर रहा है यहाँ पर, जबकि इनिशियल कंडीशन तो 0 होना चाहिए LTI सिस्टम में. तो दिस स्टेटमेंट डज नॉट फिट इट इन द कॉन्टेक्स्ट ऑफ दिस क्वेश्चन. इस क्वेश्चन के कॉन्टेक्स्ट में ही फिट नहीं होगा. इसके बारे में तो साइड में रखेंगे. Coming to this, a system is unstable if any bounded input yields an unbounded output. That is true. ये BI/BO टेस्ट फेल हो जाएगा ना, बाउंडेड इनपुट के लिए अनबाउंडेड आउटपुट आएगा, तब तो फिर अनस्टेबल ही होगा. तो फर्स्ट स्टेटमेंट ट्रू, थर्ड स्टेटमेंट ट्रू. क्वेश्चन इज विच ऑफ द स्टेटमेंट्स आर फॉल्स? फॉल्स. स्टेबिलिटी तो भूल जाइए. ये जो स्टेटमेंट है ये क्वेश्चन के कंटेक्स्ट में ही फिट नहीं होगा, क्योंकि LTA के लिए इनिशियल कंडीशन तो इन्फिनिट कहाँ से होगा. तो उस बेसिस पे आप टू ओनली को चूज कर सकते. What are the values of positive constant Kp, Kv, Ka for this system whose type is 0? See, for a type 0 system, Kv and Ka will be 0. What about Kp? That will be finite. So Kp being finite, doesn't matter what is the value. Kv, Ka both becoming 0. There is only one option, that is option D. Solve भी करने की जरूरत नहीं है. Type 0 के लिए Kp finite होगा, Kv, Ka 0 होंगे. Consider the following statements regarding properties of the transfer function. The unit of a transfer function is related to the units of the system input and output, and a unit is essential. It doesn't have any units. Transfer function का कोई unit जैसे चीज नहीं होता है. Second, the transfer function can be applied to, so this is false. The transfer function can be applied to describe only time invariant linear systems whose parameters do not change or change only little during operation. Yeah, that's what linear time invariant systems के लिए ही होता है transfer function. That's true state. Third, the transfer function is depending on the input. No, transfer function does not depend on the input. A false statement. So, which of the following statements are correct? Two only. Two only. Option D. Consider the following and give the order of the steps to be followed in performing the block diagram reduction to get the final transfer function. What is the correct sequence of steps in the block diagram reduction to obtain the transfer function? See, basically, if we whenever we want to reduce the block diagram, we always see for series parallel feedback. Series parallel feedback. सबसे पहले series देखा जाता है, उसके बाद parallel देखा जाता है, उसके बाद feedback देखा जाता है. कि सीरीज कनेक्शन हो तो पहले उसको फिनिश करो, बाद में पैरेलल हो तो उसको फिनिश करो, उसके बाद फीडबैक देखो. अगर ये तीनों से होके आ गए, उसके बावजूद अगर ट्रांसफर फंक्शन नहीं बन रहे, देन वी थिंक ऑफ शिफ्टिंग एन एडर और अ टेक ऑफ पॉइंट बिफोर द ब्लॉक, आफ्टर द ब्लॉक. ये मॉडिफिकेशन बाद में सबसे लास्ट में करना पड़ेगा. तो combined all series blocks should be the first step. Combined all parallel blocks should be the second step. Close all the feedback loops should be the third step. This should be the last step. So 1, 3, 2, 4. 1, 3, 2, 4. Option B is. Consider the following statements regarding the representation of the block diagram through signal flow graphs. Signal flow graph के through किसी block diagram को represent करना हो, क्या करें? The signal at a node is equal to sum of all the signal transmitted to that node. See, how do we write equation in signal flow graph? sum of all the incoming branches at that node. That's true. Second, the transmittance are simply related to the transfer function. Transmittance transfer function नहीं है, ये false. Transmittance simply related to the transfer function कैसे हो जाता? फिर feedback loops पूरे कहाँ जाएंगे फिर? Right. So the transmittances connected to the input and output nodes are both unity. In signal flow graph, we always secure the input and output nodes. Remember, without that Mason formula not applicable. And those input and output nodes will be drawn with the branches of unit gain to have a clarity in the signal flow graph. To separate the input node, to separate the output node, we use branches of unit gain, is what actually this statement says. See, reading the statement and understanding that, that's what is taking time. See, I myself say, like students are saying, sir, paper overloaded hai. I never have spent this much of time in giving solutions to the paper. If you see my past solutions, if it is 10 questions, I hardly take 10 minutes maximum. But for me, it is taking to explain, even for as faculty, I'm taking time to explain this question. I think I have already taken 15-20 minutes of the time, which is against my habit. So when faculty is taking time to provide solutions, understand the difficulty part for the students. So which of the above statements are correct? 1 and 3. Second statement is false. Consider the following statements regarding Nyquist. See, almost all of them. I think we had only 2 numerics out of 11 questions, 9 theory. Consider the following statements regarding Nyquist stability criteria. First statement, Nyquist stability criteria is one of the geometric criteria and graphical method in the frequency domain. Yeah, the frequency. Second, it uses open loop Nyquist diagram to judge the stability of the closed loop. That's true. We use open loop transfer function to obtain Nyquist plot, and using that we determine closed loop stability based on -1. Third, instead of solving the characteristic equation of the open loop system, the Nyquist criteria gets the stability of the closed loop system by means of open loop frequency characteristics. True. See, unlike time domain where we have to solve the characteristic equation, in frequency domain using the open loop locus, that is Nyquist, we can determine closed loops. Which of the following statements are correct? First one is correct, second one is correct, third one is correct. All 3 statements are correct. 1, 2 and 3. Right. So these are all the questions that we got from control system part. The next subject follows very shortly. Meanwhile, I want to make an announcement. Mains batch at MADE EASY is going to commence from 24th of February. February 24th से mains batch commence होगा. So I strongly recommend that every one of you join this. MADE EASY has got both offline and online coaching for this mains batch, which is going to commence from 24th February. That is greatly going to help you to understand your to improve your ability for the mains paper. And for more details, please refer to MADE EASY website regarding the batch timings and center location. You will find in the website. Thank you so much.
Evening, students. So, yeah, good evening, students. Today here we are with the solutions of engineering mathematics from electrical paper 2, okay, from the technical side.
And the questions are very simple. सारे क्वेश्चन इसके आसान रहे हैं compared to GS mathematics.
Yes.
है ना? तो पहला क्वेश्चन में क्या बोला गया है कि इसमें एक बॉक्स दिया हुआ है जिसमें 3 डिफेक्टिव है और 7 क्या है नॉन डिफेक्टिव दिए हुए हैं। बोला गया है हम लोग निकालते हैं इसमें से 2 बॉल और दोनों क्या होना चाहिए, डिफेक्टिव होना चाहिए, बेसिकली नॉन डिफेक्टिव होना चाहिए। क्या है, सिंपली द आंसर इज 7c2 डिवाइड बाई 10c2। इट इज 7 into 6 डिवाइड बाई, तो सिंप्लीफाई कर लेंगे, द आंसर इज बेसिकली 14/30 क्वेश्चन
Very simple question.
इज
But
ऑप्शन
actually, sir, this is expected, right? GS mathematics will be little out of the boundaries, and then coming to electrical paper, the mathematics will be very comfortable,
very
very
comfortable.
limited and very conceptual.
Again, question from probability. It is asking about the probability of x and that is equal to sum of both dice, sum of 2 dice. और बोला गया कि जो probability है it should be greater than 4 and less than equal to 8, ये पूछा गया है। अगर आपको याद होना चाहिए, मतलब हमसे पूछ रहा है probability of x equal to 4 sum of dice plus probability of x equal to 5 plus probability of x equal to 6 plus probability of x equal to 7 and plus probability of x is equal to 8। तो 4 के लिए जैसे आपको बताया हो n-1 दैट इज 8, तो 4 के लिए हमारे पास कितना हो जाएगा 3, 5 के लिए कितना हो जाएगा 4, 6 के लिए कितना केस आते हैं 5, 7 के लिए केस कितना 6, 8 के लिए कितना केस 5, सबको याद होना चाहिए, डिवाइड बाय 36, दिस इज द आंसर। तो बेसिकली द आंसर इज 23/36। हमने बताया होगा कि सब ऑफ डाइस के लिए लेस देन 7 अप टू 7 के लिए n-1 एंड आफ्टर 7 वी आर हैविंग 13-n।
Yes, sir.
Go with the next question, sir.
So next question is same again, the very basic and regular question. So there is a box of 7 green and 5 yellow, right? And 2 balls are selected at random, one at a time. That means one after the other. And the question is that the selection is made with the replacement. That means one is removed and then it is replaced. So sample space remain every time same here. So what is the probability that the 2 balls are going to be at different colors? So as it is a sequence here, so there is a one chance. So there are 2 chances here. So what is that is here, 2 different colored balls means here, let us suppose that E is equal to 2 different colored balls. So first one is green and second one is of yellow, then or first one is yellow and then one is green here. So either this will happen or this will happen here. So this is given by the total probability of this green into probability of yellow plus probability of yellow into probability of green. So this is going to be here, green means 7/12, right? 7/12 and then 5/12, because with replacement है तो sample space बराबर होगा, तो into 2 कर लीजिए because both are same here. So this is going to be here 35/72.
60. 35/72.
Yes, 35/72 is going to be the answer.
Is option D.
Yes, that is option D here. Fine, easy question. Now coming to this one, if the 2 events A and B are such that here, generally here we used to have this P of A intersection B, but it is given as union, and B of A, P of B and P of A union B. So using addition theorem we can find out the P of A intersection B from it. Why? Because he is asking about B by A, as it is a conditional probability as per that multiplication theorem, and we can write this, we can find this one. So as intersection is given by using the addition theorem, here it is 0.6 plus 0.3 minus 0.7, 0.6 plus 0.2, 0.2, right? Divided by 0.6 here. So this is 0.1 by 0.6. So it is 1/6 here. So option B is the right answer. Very straight questions and simple questions here. Now coming to this question, it is a binomial distribution. So always we used to say that these are the parameters of the distribution. Every distribution have their own parameters. So this is n and this is p here, right? And n is given as 16 and p is given as half. So it implies q is 1 minus p, which is half here, right? And variance of the random variable, क्या बोलते हैं? ये तो बाइनोमियल डिस्ट्रीब्यूशन का है, बाइनोमियल रैंडम वेरिएबल का वेरिएंस डायरेक्ट क्वेश्चन है, NP/Q और फॉर्मूला है. तो यहाँ पर 16 into 1/2 into 1/2. So this goes to be 4. So option B is the right answer for this.
नेक्स्ट
Carry on,
क्वेश्चन इज फ्रॉम नॉर्मल डिस्ट्रीब्यूशन. अगेन देखो क्या दिया है इसमें, नॉर्मल डिस्ट्रीब्यूशन का क्वेश्चन है, एंड दैट इज बेसिकली पैरामीटर ऑफ म्यू एंड सिग्मा स्क्वायर. एंड हियर इफ यू कंपेयर विद दिस, इट इज अ नॉर्मल डिस्ट्रीब्यूशन, इट इज गिवन एज 15 and it is given as 6.25. just compare, you are having mean is equal to 15 and sigma square equal to 6.25, which means sigma is equal to 2.5. अब हमसे पूछा क्या है, हमसे पूछा है x का वैल्यू बताइए, which is equal to mu minus sigma 1.2 times of sigma. 1.2 times of sigma.
Just substitute this value.
So mu are, we are having 15 minus 1.2 into sigma, we are having 2.5, which is 15 minus 3.
15 minus 3, 12.
The answer is 12. Simple question.
Oh, sorry.
The answer is option A here. This is the question here, and I think in this question some data is missing. Basically h का वैल्यू दिया हुआ है, it is 2 minus 1.5 times of sin t, और t का रेंज हमको दिया हुआ है 0 से लेके 3, और इन बिटवीन अगर हम बात करें कि इसका वैल्यू मैक्स चाहिए, अगर h मैक्स चाहिए तो h मैक्स तब होगा जब ये पूरा टर्म मैक्सिमम होगा, और ये पूरा टर्म मैक्सिमम तब होगा जब साइन का वैल्यू क्या होगा, यहाँ माइनस साइन है तो ये वैल्यू अगर जब मिनिमम होगा तो मैक्स होगा, और इसका मिनिमम वैल्यू कितना होगा, -1. -1 अगर है तो ये हो जाएगा हमारे पास 2.15 एंड दैट इज 3.5. अच्छा, ये मिनिमम कब होगा, जब x का वैल्यू हमको मिलेगा, t का वैल्यू हमारे पास क्या चाहिए, बेसिकली कह सकते हैं कि
मैक्सिमम मुझे मैक्सिमम
मैक्स की बात कर रहे हैं, बट हमको साइन t का वैल्यू चाहिए कितना,
मैक्सिमम वैल्यू इज 1 at pi by 4, pi by 2.
बट वी वांट सर, इफ इट वांट h मैक्स तो इसका वैल्यू चाहिए हमको मिनिमम वैल्यू -1 चाहिए, तो -1 कब होगा हमारे पास, जब t का वैल्यू
इंटरवल का नहीं,
तो इट इज नॉट इन द इंटरवल. तो अगर मुझे मैक्स चाहिए तो इसका वैल्यू हमारे पास 1 होगा,
तो
जो कि
zero
इंटरवल
लेना
में है. तो अगर इंटरवल
अगर t is equal to 0 के लिए 0 लेते हैं तो देन इट इज
Is
कमिंग अराउंड 2 here,
so we can have the answer as 2.
and it is comes around 2 here.
Yes, the answer is 2.
Yes,
Right.
perfect. So here it's a very direct question, beta direct properties के based
Yes.
question है. Consider the following statement. Which of the following statements are regarding the rank in terms of the column vectors here is not correct. He said not correct. Let's see. The rank of matrix is equal to the maximum number of linearly independent column vector. This is the definition of the rank. We cannot ignore it. It's true here, right? The matrix A and A transpose have the same rank. So this is also true here. Then consider P vectors is having n components. So P vectors are having n components. Suppose two vectors are having 3 components. So that is something like it is 2 cross 3 matrix here. It is 2 cross 3 matrix. So if n less than P here, if n less than P means तो components कम होना चाहिए और ये vector ज़्यादा होना चाहिए. तो मतलब 3 vector 2 components if you take, so then it can be understood as a matrix of, if I put these vectors into a matrix, it will be of 3 by 2. So rank of A 3 by 2 is less than or equal to 2. Less than or equal to 2 here it is, right? So as it is less than or equal to 2, तो number of independent कम है, मगर यहाँ पर कितने वेक्टर है, 3 वेक्टर है, तो हमारे 2 वेक्टर ही इंडिपेंडेंट है, तो मतलब तीसरा वेक्टर पक्का डिपेंडेंट होना चाहिए. So because of this, so linearly independent is wrong. So therefore 3 only is the right answer. It's a direct question beta. Directly it is eigenvalue का definition है, direct. So is the solution of the
Simply
eigenvector.
it is a minus lambda I into x is equal to 0, which is option A here.
Option A, direct. So this is Fourier series question. You know that A naught. So using this concept of mathematics, if you do it, 1 by L integral,
Minus pi
where
to
the
pi.
interval is given as minus pi
Pi to
to pi here. So as the interval is minus L to L is equal to minus pi to pi, so L is equal to pi here. So therefore this is directly I can write it as L 1 by pi and then minus pi to pi f of x dx here. But you know this function is defined as n to x only in this interval and as well as in this interval. So we have to integrate this function in these intervals. So it becomes 1 by pi of this integral minus pi to minus pi by 2 of sine 2x dx plus and then 0 to pi sine 2x dx. So this is what we have to calculate here. So I think you are getting
1
about
upon
1
pi.
by pi. So this is the answer for this integration. Directly you can see. So coming to next question, sir.
This is question which is a kind of, you can say, the straight line this with a b c are constant and c के बारे में बताया गया एक constant vector है. बोला गया है कि has a finite radius of curvature at every point, zero radius of curvature at every point. तो अगर बात करें, अगर straight line की अगर definition की बात करें, what is definition of a straight line? तो मैं बोल सकता हूँ कि straight line जो है एक circle है जिसका radius कितना होगा, radius हम ले सकते हैं उसका कितना, infinite. We can say a straight line is a circle whose radius is infinite. इसका मतलब हुआ कि an infinite radius of curvature at every point. That is option C here.
And it becomes a straight line. And again it's a direct question.
See in this question कह रहा है any square matrix A and its transpose A transpose have same eigen value. A और A transpose का eigen value same होता है. कह रहा है मैट्रिक्स अगर triangular matrix है तो उसके eigen value उसके diagonal element होंगे. That is also correct statement. कह रहा है the sum of eigen value of the matrix is product
This
is the product of the element. मतलब sum जो है trace के बराबर होता है. तो basically
नहीं, ये प्रोडक्ट पूछ
प्रोडक्ट बोला
ये
हुआ
गलत
है.
है.
This statement is गलत.
स्टेटमेंट इज
Basically that is वो सम के बराबर होना चाहिए, ट्रेस के बराबर होना चाहिए.
190.
The answer is 1 and 2.
यहाँ पर R be the rank of the coefficient of the R be the rank of that okay matrix and system is homogeneous. So AX is equal to 0 and he has given the rank of A and he said that there are m number of equations and n number of unknowns. So definitely this matrix is going to be of m cross n, right? So this is a m cross n here. So because you see that there are m number of equations, that means m rows and n columns will be there because n number of unknowns are there. So rank of this one is minimum less than or equal to minimum of m comma n, that you see it, right? So as per this, if you see, if r is less than n, that means the rank is getting less than n. So it is very clear that so there are some dependent rows are there. So dependent equations are there, because of that infinitely many solutions are possible. जब infinitely many solutions possible है, the number of independent solutions are given by number of unknowns minus rank of this matrix. This is a straight away formula for the nullity of the matrix. So therefore it is true here. Which is not correct, he is asking. He is asking which is not correct. So this is true here, right? If m less than n, then the number of solutions is finite here. But actually जब equations कम unknown ज़्यादा है तो पक्का ये नो सोल्यूशन अंडर डिटरमाइंड सिस्टम बोलते हैं इसको, नो सोल्यूशन में आ सकते हैं, नहीं तो इन्फिनिटली सोल्यूशन में आ सकते हैं. तो फाइनाइट बोल के नहीं बोलना है, तो ये फॉल्स है बेटा, ठीक है. तो ये इफ m इज इक्वल टू n देन सच सोल्यूशन इज नॉन ट्रिवियल सोल्यूशन. वी आर नॉट श्योर, we are not sure trivial also. So this is also false here. So 2 and 3. So this is the right answer for this. So that's it, my dear students. With this we are concluding the maths.
So overall we can say the mathematics is easy side,
very easy part better, right?
Thank you.
ओके तो दोस्तों स्वागत है आपका. अभी सिग्नल एंड सिस्टम के जो क्वेश्चंस हैं वो हम लोग 1 बाय 1 देखेंगे, ठीक है. सबसे पहले फर्स्ट क्वेश्चन एक बार स्टेटमेंट रीड करते हैं। द सिग्नल स्पेस शुड बी डिवाइडेड एज, ऑप्शंस आर, इन सारे ऑप्शंस में आप देखो तो क्या लिखा गया है, द सिग्नल स्पेस शुड बी डिवाइडेड एज आइदर पीरियोडिक और नॉन पीरियोडिक। करेक्ट है, क्योंकि सिग्नल दोनों टाइप का होता है, पीरियोडिक एंड नॉन पीरियोडिक। आगे देखें, वेयर एज द सिस्टम शुड बी आइदर टाइम स्केलिंग और शिफ्टिंग। तो सिस्टम जनरली देखें तो दो टाइप के होंगे, वो या तो शिफ्टिंग प्रोवाइड करेंगे, मतलब या तो डिले या फिर टाइम एडवांस। देखिए वैसे जनरली देखें तो टाइम डिले ही प्रोवाइड करते हैं, या फिर टाइम स्केलिंग, मतलब वो या तो कॉम्प्रेस करेंगे सिग्नल को या फिर एक्सपेंड करेंगे। तो ऑप्शन सी इज करेक्ट। नेक्स्ट क्वेश्चन देखते हैं। कंसिडर अ नॉन रिकर्सिव फिल्टर विद द इम्पल्स रिस्पॉन्स एच एन शोन इन द फिगर बिलो। तो एक नॉन रिकर्सिव फिल्टर है जिसका इम्पल्स रिस्पॉन्स एच एन गिवन है। व्हाट इज द ग्रुप डिले इन टर्म्स ऑफ फ्रीक्वेंसी। तो हमें ग्रुप डिले बताना है कि क्या होगा। इसका एक फंडा ऐसा है कि आप एच एन को देख करके पहले एक सिग्नल ड्रॉ करेंगे H1n, और H1n ये देखने में कैसा होगा, रियल एज वेल एज इवन। रियल इवन का मतलब जैसे आपने इसको इस तरह ड्रॉ किया, फर्स्ट सैंपल सेकेंड थर्ड, मतलब इस तरह इवन। अब इसका नेचर कैसा हो गया, ओवरऑल रियल इवन। H1n रियल इवन है, तो इसका जो DTFT होगा, मतलब ट्रांसफर फंक्शन h ऑफ e की पावर H1 e की पावर j ओमेगा, बेटा इसका नेचर भी कैसा होगा, रियल इवन। और अगर H1 e की पावर j ओमेगा रियल इवन है तो रियल तो है, और अगर रियल है तो फेज कितना होगा, ज़ीरो होगा। H1 e की पावर j ओमेगा का फेज कितना होगा, ज़ीरो, क्योंकि रियल है तो इमेजिनरी पार्ट ज़ीरो है। फिर अगर h ऑफ n को H1 से रिलेट करें तो H1 को आप 2 का राइट शिफ्ट करो तो Hn मिलेगा। तो आप इसको लिख सकते हैं H1n-2, मतलब H1 को 2 का राइट शिफ्ट करो Hn मिलेगा। अब यहाँ से आपने फेज कैलकुलेट किया तो पहले DTFT अप्लाई करो, तो DTFT आप इस फॉर्म में लिखेंगे, ठीक है। एक मिनट, e की पावर -j2 ओमेगा। फिर यहाँ से जब आप फेज कैलकुलेट करेंगे तो फेज ऑफ h ऑफ e की पावर j ओमेगा, देखो इसका फेज 0 है, प्लस इसका फेज -2 ओमेगा है, तो फेज कितना आया, -2 ओमेगा। और हमें कैलकुलेट क्या करना है, ग्रुप डिले का फॉर्मूला क्या है, माइनस डेरिवेटिव ऑफ फेज विथ रेस्पेक्ट टू ओमेगा। इसको डिफरेंशिएट करो, माइनस से मल्टीप्लाई करो, कितना आएगा, 2 आएगा। तो आंसर कौन सा ऑप्शन होगा, ऑप्शन बी, क्योंकि ऑप्शन बी में आंसर कितना है, 2। नेक्स्ट क्वेश्चन देखते हैं। नेक्स्ट क्वेश्चन, इफ h ऑफ t इज गिवन, ठीक है, देन द फंक्शन इज, हमें बताना है जो फंक्शन है कॉजल है, स्टेबल है, क्या है, नॉन कॉजल है, अनस्टेबल है, क्या है। अब इसमें क्या करेंगे, यहाँ जो दो फंक्शंस है, इन दोनों फंक्शन से क्या मल्टीप्लाइड है, u ऑफ -t। तो आप इसको अगर 3 पार्ट्स में लिखे, -2/3 e की पावर t इंटू यू टी, प्लस 2/3 e की पावर -2t इंटू यू टी, u ऑफ -t, सॉरी यहाँ पर क्या लिखना है, u ऑफ -t, ठीक है, थोड़ा सा करेक्शन किया हमने, u ऑफ -t। नेक्स्ट टर्म है 2/3 e की पावर -2t इंटू यू ऑफ -t, और थर्ड टर्म है डेल्टा t। आप अगर इम्पल्स रिस्पॉन्स h ऑफ t को देखें तो h ऑफ t इज नॉन जीरो फॉर t लेस देन 0। कॉजिलिटी के लिए क्या होता है, इम्पल्स रिस्पॉन्स एच टी LHS में 0 होना चाहिए, बट यहाँ पर u ऑफ -t है, इट मीन्स इम्पल्स रिस्पॉन्स एच टी इज नॉन ज़ीरो फॉर t लेस देन 0। तो सिग्नल या फिर सिस्टम का नेचर कैसा है, नॉन कॉजल। व्हाट अबाउट स्टेबिलिटी के बारे में कमेंट करने के लिए रीजन ऑफ कन्वर्जेंस लिखना पड़ेगा। अब अगर आप इसका ROC लिखें, रीजन ऑफ कन्वर्जेंस, तो फर्स्ट टर्म का ROC है सिग्मा लेस देन 1, सेकेंड का ROC है सिग्मा लेस देन -2, और थर्ड टर्म का ROC डेल्टा टी का ROC एंटायर एस प्लेन। अब इन तीनों से कॉमन ROC लिखना है, तो इन तीनों से कॉमन ROC आप क्या लिखेंगे, आप h ऑफ t के लिए कॉमन ROC लिखते, कॉमन ROC आप h ऑफ t का लिखते सिग्मा लेस देन -2, सिग्मा लेस देन -2. नाउ दिस ROC इज द कॉमन ROC, और ये जो ROC है, दिस ROC इज नॉट इंक्लूडिंग j ओमेगा एक्सिस. इसका मतलब सिग्नल कैसा है, अनस्टेबल टाइप का है, मतलब नॉट एब्सोल्युटली इंटीग्रेबल, अनस्टेबल टाइप का सिग्नल है. तो एच ऑफ टी कैसा है, अनस्टेबल, और एच ऑफ टी का नेचर कैसा, नॉन कॉजल. तो कौन सा ऑप्शन आंसर है, ऑप्शन डी. नेक्स्ट क्वेश्चन देखते हैं. द यूनिट इम्पल्स रेस्पॉन्स ऑफ एन LTI सिस्टम इज HT एंड HT इज गिवन. व्हाट इज द रेस्पॉन्स टू इनपुट XT बाय यूजिंग द लैप्लास ट्रांसफॉर्म. तो बेटा यहाँ पर एक फंडा यूज़ करना है. सबसे पहले साइनोसोडल इनपुट है, ओमेगा नॉट कैलकुलेट करो, कितना है 1. अब साइनोसोडल इनपुट के लिए आउटपुट YT कैलकुलेट करना है, तो फॉर्मूला क्या, मॉड H ओमेगा नॉट इंटू साइन P प्लस फेज ऑफ H ओमेगा नॉट. मतलब हमें क्या कैलकुलेट करना है, मैग्नीट्यूड एंड फेज. इसका कैलकुलेट करना है H ओमेगा नॉट का. अब H ओमेगा नॉट चाहिए, तो पहले H ऑफ T से क्या लिखोगे, H ऑफ S. H ऑफ S आप यहाँ से लिखते 2 अपॉन S प्लस 1 होल स्क्वायर प्लस 2 स्क्वायर. तो हमने क्या लिख दिया, H ऑफ S. फिर H ऑफ S में S को j ओमेगा से रिप्लेस करना, तो क्या मिलेगा, H ऑफ ओमेगा. फिर H ऑफ ओमेगा में ओमेगा को पुट करना, ओमेगा नॉट. ओमेगा नॉट की वैल्यू कितनी है, 1. तो क्या मिलेगा, H ऑफ ओमेगा नॉट. फिर यहाँ से दो वैल्यूज़ आपको कैलकुलेट करने होंगे. कौन कौन से वैल्यूज़, H ऑफ ओमेगा नॉट एंड फेज ऑफ H ओमेगा नॉट. जब आप इस प्रोसेस को यूज़ करेंगे, कैलकुलेशन करेंगे, तो आंसर मैच होता है ऑप्शन डी. क्योंकि मॉड H ओमेगा नॉट हमने कैलकुलेट किया है, कितना आता है 0.447. फेज H ओमेगा नॉट भी हमने कैलकुलेट किया, कितना आता है -26.66 डिग्री. तो बेटा आंसर कौन सा ऑप्शन है, ऑप्शन डी. आगे बढ़ते हैं. नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन में अगर आप देखें तो डाटा क्या है, x ऑफ n इज गिवन, व्हाट इज द वैल्यू ऑफ yn इक्वल टू x ऑफ 2n. इसमें से कौन सा ऑप्शन आंसर है, ये बताना है. इसका मतलब यहाँ पर डेसिमेशन का प्रोसेस है. डेसिमेशन में जैसा आपको मालूम है, आपको एवरी सेकेंड सैंपल कलेक्ट करना है. सैंपल कलेक्शन स्टार्ट करना है ओरिजिन से. तो एवरी सेकेंड सैंपल कलेक्ट करो, तो ये सैंपल्स कलेक्ट होंगे. मतलब y ऑफ n विच इज़ x ऑफ 2n, सैंपल्स क्या मिलेंगे, 1 1 1 1. कितने वंस हैं, 4 वंस है. इसको क्या लिखोगे, un माइनस u ऑफ n माइनस 4. अब चेक करो कोई ऑप्शन है क्या, कौन सा ऑप्शन है, ऑप्शन सी. तो कौन सा ऑप्शन मैच हुआ, ऑप्शन सी. आगे बढ़ते हैं. नेक्स्ट क्वेश्चन अच्छे से रीड करो. कंसिडर अ फाइनाइट ड्यूरेशन सीक्वेंस सच एज x ऑफ n इज गिवन. ओके, व्हाट इज द न्यू सीक्वेंस प्रोड्यूस्ड व्हेन इट रिवॉल्व्स 4 यूनिट्स इन द सर्कुलर ऑपरेशन. मतलब इसे सर्कुलर शिफ्टिंग करना है 4 टाइम्स. मतलब आपको सर्कुलर शिफ्ट करना है x ऑफ n माइनस 4 मॉड n ऑपरेशन. नंबर ऑफ सैंपल्स कितने हैं, 5. तो मॉड n में यहाँ n की वैल्यू कितनी है, 5 है. अब अगर आप इसे 4 टाइम्स राइट शिफ्ट करोगे, 4 टाइम्स आप राइट शिफ्ट करोगे, तो जब भी राइट शिफ्ट करते हैं तो लास्ट सैंपल को फर्स्ट में लिखते हैं. मतलब फर्स्ट टाइम राइट शिफ्ट करोगे तो 16 आगे आएगा. फिर उसके बाद सेकेंड टाइम राइट शिफ्ट करोगे तो फिर 8 आगे आएगा. थर्ड टाइम राइट शिफ्ट करोगे तो 4 आगे आएगा. 4 टाइम राइट शिफ्ट करोगे तो 2 आगे आएगा. ठीक है, और लास्ट सैंपल कितना होगा, 1. अब अगर आप चेक करो तो कौन सा ऑप्शन मैच हो रहा है, कौन सा ऑप्शन मैच हो रहा है, ऑप्शन बी. बट यहाँ पर एक चीज़ और है. अगर आप 4 टाइम्स लेफ्ट शिफ्ट करेंगे, अगर आप 4 टाइम्स लेफ्ट शिफ्ट करेंगे तो ऑप्शन डी भी मैच होता है. ये जो मैंने लिखा है, ये मैंने क्या लिखा है, x ऑफ n माइनस 4 मॉड n ऑपरेशन, मतलब 4 टाइम्स राइट शिफ्ट के साथ. और ये जो ऑप्शन है, दिस ऑप्शन इज x ऑफ n प्लस 4 विथ मॉड n ऑपरेशन. मतलब अगर कोई 4 टाइम्स लेफ्ट शिफ्ट करता है तो कौन सा ऑप्शन आएगा, ऑप्शन डी. मतलब सेम क्वेश्चन में बेटा 2 ऑप्शन आंसर हैं. कौन कौन से, ऑप्शन बी एंड ऑप्शन डी. एक बार क्रॉस चेक कर लेना चाहिए मुझे, कौन सा क्वेश्चन है ये. इसमें अगर क्रॉस चेक करें तो बी एंड डी ठीक है, करेक्ट है. मतलब बी भी हो सकता है, डी भी हो सकता है. बट प्रैक्टिकली देखें तो जनरली हम लोग टाइम डिले को कंसिडर करते हैं तो मोस्ट अप्रोप्रिएट अगर मैं बताऊं तो ऑप्शन बी को माना जा सकता है, क्योंकि टाइम डिले प्रैक्टिकल केस है, क्योंकि आप इनपुट अप्लाई करते हैं तो थोड़ा डिलेड होता है। तो मोस्ट अप्रोप्रिएट ऑप्शन बी रख सकते हैं। बट अगर बोला जाए कि अगर मतलब दोनों केसेस पॉसिबल है कि नहीं, तो बिल्कुल पॉसिबल हैं। बी भी हो सकता है, डी भी हो सकता है। आगे बढ़ते हैं। व्हाट इज द लीनियर कन्वोल्यूशन रेस्पॉन्स y ऑफ 5 ऑफ द गिवन सीक्वेंस। तो x ऑफ n गिवन है और h ऑफ n गिवन है, और y ऑफ n कैलकुलेट करना है। कैसे कैलकुलेट होता है? x ऑफ n कन्वोल्यूशन विथ h ऑफ n से। बेटा अगर आप n के वैल्यू 0 1 2 3 4 5, यहाँ देखो रेंज क्या है, 0 1 2 3 4 5, मतलब x ऑफ n में 6 सैंपल्स लिखने हैं। अगर आप x ऑफ n में 6 सैंपल्स लिखेंगे तो वो सैंपल्स मैंने लिखे हैं, वो सैंपल्स क्या हैं, वो इस फॉर्म में आएंगे 0 1 1 0 -1 -1, और h ऑफ n के सैंपल्स गिवन है। इसको एज इट इज यहाँ पर पुट कर देना। इसके बाद इसको क्या करना है, कन्वॉल्व। लीनियर कन्वोल्यूशन बोला गया है तो टैबुलर मेथड ऑफ कन्वोल्यूशन यूज कर लेना। जब आप टैबुलर मेथड ऑफ कन्वोल्यूशन यूज करोगे तो आंसर आएगा 0 1 3 5 4 0 -4। आगे बढ़ते हैं, -5 -3 एंड -1। ठीक है। अब इसमें अगर आप चेक करेंगे तो y ऑफ 5, ओके, यहाँ पर एरो लोकेटेड है फर्स्ट एलिमेंट पर, y ऑफ 0 1 2 3 4 5, तो दिस एलिमेंट इज y ऑफ 5। तो हमने y ऑफ 5 कैलकुलेट कर लिया। y ऑफ 5 की वैल्यू कितनी आई, अगर आप देखें तो y ऑफ 5 कितना आया, 0। ऑप्शन मैच करो, कौन सा ऑप्शन मैच होगा, ऑप्शन ए। आगे बढ़ते हैं, नेक्स्ट क्वेश्चन देखते हैं। नेक्स्ट क्वेश्चन, बाय यूजिंग द 3 पॉइंट DFT ऑफ द सीक्वेंस h ऑफ n गिवन है, n का रेंज है 0 to 2, मतलब कितने सैंपल्स हैं बेटा, 3 सैंपल्स हैं। मतलब यहाँ DFT में n की वैल्यू कितनी है, 3, और h ऑफ n में n के वैल्यूज़ को क्या क्या पुट करना है, 0 1 2। 0 पुट करोगे 1, 1 पुट करोगे a इनवर्स, 2 पुट करोगे a की पावर -2। अच्छा, एक ऐसा है रियल है, अच्छे से देखो, एक ऐसा है रियल है। अगर a रियल है तो h ऑफ n बताओ कैसा सिग्नल है, रियल सिग्नल है। और अगर h ऑफ n रियल सिग्नल है तो मैंने ये चीज़ क्लास में डिस्कस किया है। क्या डिस्कस किया है, h ऑफ k विल बी इक्वल टू h कंजुगेट n माइनस k। तो इस रिलेशनशिप को यूज़ कर सकते हो, लेकिन कब यूज़ कर सकते हो, जब h ऑफ n कैसा सिग्नल होगा, रियल। अभी कैसा है, रियल। यहाँ से अगर आप आगे लिखे k का वैल्यू 1 पुट करें तो आप लिखते h ऑफ 1 विल बी इक्वल टू, बेटा n कितना है 3, k कितना पुट कर रहे हो 1, तो क्या लिखते h ऑफ 2 कंजुगेट, या फिर लिखते h ऑफ 1 कंजुगेट विल बी इक्वल टू h ऑफ 2। अब एक बार देखो तो कौन सा ऑप्शन मैच हुआ, h2 इज इक्वल टू h1 कंजुगेट, कौन सा ऑप्शन मैच हुआ, ऑप्शन डी। आगे बढ़ते हैं, नेक्स्ट क्वेश्चन देखते हैं। If x of s is Laplace transform of xt, what is the initial value x of 0 and the final value x of infinite respectively for the given signal x of s given है, और हमें दो वैल्यूज कैलकुलेट करना है, कौन कौन सा, इनिशियल वैल्यू और फाइनल वैल्यू। और इसने साफ साफ बोला है क्या यूज़ करना है, इनिशियल वैल्यू एंड फाइनल वैल्यू थ्योरम। तो अगर x t इक्वल टू 0 पर चाहिए तो क्या यूज़ करते हो, थ्योरम। क्या लिखते हो, लिमिट s टेंस टू इन्फानाइट x ऑफ s। अच्छा, इसको s से मल्टीप्लाई करोगे तो क्या रह जाएगा, 7s प्लस 6 अपॉन 3s प्लस 5, और लिमिट का कंडीशन क्या, लिमिट s टेंस टू इन्फानाइट। ठीक है। ओके, और s टेंस टू इन्फानाइट के साथ इन दोनों को इग्नोर करो तो कितना आया, 7/3। ओके, और अगर फाइनल वैल्यू कैलकुलेट करना है x ऑफ इन्फानाइट तो क्या लिखते हो, लिमिट s टेंस टू 0 s इंटू एक्स ऑफ s, मतलब यही वाला रेशियो आने वाला है क्योंकि वो s इंटू एक्स ऑफ s है। उसमें s को क्या पुट करोगे, 0, कितना आएगा 6/5, तो x ऑफ 0 7/3, x ऑफ इन्फानाइट 6/5, यहाँ ऑप्शन डी होगा। क्लियरली आपको नहीं दिख रहा है बट यही है क्योंकि यहाँ 7/3 है, इधर 6/5 है। आगे बढ़ते हैं, आगे देखते हैं नेक्स्ट क्वेश्चन क्या है। ठीक है। 40 के बाद क्वेश्चन नंबर 59 सिग्नल से ही रिलेटेड है। द डायोड फॉल्स अंडर विच टाइप ऑफ सिस्टम, स्टेबल है, अनस्टेबल है, आइदर स्टेबल और अनस्टेबल एंड सो ऑन। चेक करना है कि डायोड क्या है। अच्छा, डायोड में आप एक रिलेशनशिप लिखते हैं, डायोड करंट इज इक्वल टू आई नॉट फिर ई की पावर डायोड वोल्टेज अपॉन ईटा वी टी -1। अच्छा, डायोड करंट क्या रिप्रेजेंट करता है, आउटपुट बाई टी। आप डायोड को एज ए सिस्टम कंसिडर करेंगे और ये जो डायोड वोल्टेज है ये क्या रिप्रेजेंट करता है, इनपुट एक्स टी ईटा वी टी -1। अब ये जो रिलेशनशिप है इस पर बी आई बी ओ क्राइटेरिया अप्लाई कर लो। बी आई बी ओ क्राइटेरिया के अकॉर्डिंग जो भी आंसर आएगा वो लिखना है। अगर आप इनपुट को फाइनाइट अप्लाई करेंगे तो आउटपुट भी फाइनाइट आने वाला है, ठीक है। तो जब आप इनपुट को कोई फाइनाइट एम्पलीट्यूड प्रोवाइड करोगे तो ई का पावर फाइनाइट वैल्यू इज ऑलवेज फाइनाइट। फाइनाइट में से -1 गया तो फाइनाइट ही आएगा, और आई नॉट कांस्टेंट है, फाइनाइट होता है तो आउटपुट भी फाइनाइट आएगा। मतलब बी आई बी ओ क्राइटेरिया फॉलो होगा, क्योंकि आपने एक्स टी को कैसा प्रोवाइड किया, बाउंडेड इनपुट, ठीक है। और बाउंडेड इनपुट का मतलब क्या है, फाइनाइट एम्पलीट्यूड का इनपुट, और आउटपुट भी कैसा मिलेगा, वाई टी मिलेगा बाउंडेड, ठीक है। तो वाई टी मिलेगा बाउंडेड, तो बी आई बी ओ क्राइटेरिया फॉलो हो गया। तो सिस्टम कैसा है, स्टेबल है, स्टेबल है। तो कौन सा ऑप्शन मैच होगा, ऑप्शन ए। आगे बढ़ते हैं, आगे देखते हैं। विच ऑफ द फॉलोइंग प्रॉपर्टीज ऑफ कन्वोल्यूशन सिस्टम एग्जिबिट्स और एग्जिबिट द रिजल्ट ऑफ सुपरपोजिशन प्रिंसिपल फॉर यूनिट इम्पल्स रेस्पॉन्स इन लीनियर टाइम इनवेरिएंट सिस्टम। तो उसने बोला सिस्टम कैसा, एल टी आई। फिर इसने बोला कि सिस्टम का आउटपुट वाई टी कैसे मिलेगा, कन्वोल्यूशन से। कन्वोल्यूशन में क्या करते हो, एक्स टी और एस टी को क्या करते हो, कन्वॉल्व। अच्छा, फॉर्मूला क्या यूज़ करते हो, इंटीग्रेशन माइनस इन्फानाइट टू इन्फानाइट एक्स टाउ एच ऑफ टी माइनस टाउ डी टाउ। अब इसने बोला कि ये जो आउटपुट है इसके कैलकुलेशन में जो कन्वोल्यूशन यूज़ किया। अब कन्वोल्यूशन में कौन कौन सा प्रॉपर्टी यूज़ होता है, तो बेटा डिस्ट्रीब्यूटिव भी यूज़ होता है, एसोसिएटिव भी यूज़ होता है। क्योंकि आपने यहाँ टाउ का वैल्यू रेंज पुट किया ना, तो टाउ का अलग अलग वैल्यू पुट करोगे तो डिस्ट्रीब्यूट हो रहा है, फिर उसके बाद हमें ऐड करना है तो एसोसिएट भी हो रहा है। और बाय द वे आप कन्वोल्यूशन यूज़ कर रहे हैं तो यहाँ कन्वोल्यूशन में एसोसिएटिव प्रॉपर्टी भी फॉलो हो रहा है और डिस्ट्रीब्यूटिव भी प्रॉपर्टी फॉलो हो रहा है। तो दोनों प्रॉपर्टी फॉलो हो रहा है, तो कौन सा ऑप्शन मैच होगा, ऑप्शन बी। तो बेटा हमने सिग्नल के सारे क्वेश्चन देख लिए हैं, अभी ये सब्जेक्ट तो कंप्लीट हो गया है, बस थोड़ा देर वेट कीजिए, नेक्स्ट सब्जेक्ट का आंसर आपको मिलेगा अभी।
Yeah, welcome to the Digital Electronic Solution Session. Let us check the questions here. Yeah, these are the theoretical questions and this is the question related to the DAC. In the case of DAC, always I used to say the resolution related you will get the question. Exactly the same way you got the question here related to the resolution. You check this one, how to solve this. They said what is the percentage resolution they are asking, and they gave this is the 8-bit. Percentage resolution for that, percentage resolution is nothing but 1 by 2 power n minus 1 into 100. So, here n is 8-bit, so 1 by 2 power 8 minus 1 into 100. So, it is going to be 1 by 255 into 100. So, that you may get this answer is of option B. Remaining the questions they give theoretical question, like this question is related to the question related to counter next state, like that to check it. As you know, gray code is the code where we are having from successive numbers we are going to have only 1 bit change. That's why obviously can expect the answer for that. And here this one is related to the bus, they asked the question which gate can be used. It will be the buffer gate. These are the real theoretical questions. Directly you can get the answers for that. And the only question that they gave the problem, that too so simple one, is related to the DAC percentage resolution. Got it? Right. Thank you.
Hello, 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 my dear students. Voice. Hello. Hello, my dear students. I am here to explain the video solutions for power electronics. So, as far as the power electronics is concerned, questions are very easy questions this year. So, very easily you can answer all the questions, right? Let us go through the first question in power electronics. The diode circuit consists of a diode in series with the switch S1, resistance R is equal to 44 ohms, capacitance 0.1 microfarad. The capacitance has initial voltage of 220 volts. If the switch S1 is closed at t is equal to 0, what is the energy dissipated in the resistor? Okay. So, let me draw the I will give the solution for this question. So, switch is closed at t is equal to 0 seconds. So, here the capacitor voltage at t is equal to 0 seconds, it is 220 volts. Okay. Small correction here. These are the polarities. Okay. The moment you turn on the switch at t is equal to 0, capacitor discharges energy into the resistor. That means the energy of the capacitor is half CV square, that is dissipated in I square R losses. I square R losses. That means here capacitor is discharging energy in the resistance. Okay. That means as per the energy balance equation, I square RT here, as per the energy balance equation, power dissipated in the resistor, energy loss in the resistor, not power dissipation, energy loss in resistance is nothing but capacitor discharging energy. So, what is the capacitor discharging energy here? So, this is the capacitor voltage at t is equal to 0 seconds, which is 220 volts. So, that is just energy balance equation, half into the value of capacitance is 0.1 microfarads, 0.1 into 10 to the power minus 6, initial voltage is 220 volts whole square. Just calculate this value, 2.42 millijoule. So, for the question 2.42 millijoule is the answer. Okay. So answer is option D. Dear students, answer is option D. Please once again go through this question. Yes, here capacity is discharging energy and that is dissipated in I square R losses. Just I used energy balance equation. I hope it is clear to you. Yes. Let us go back to the next question. Which of the following is not a limitation of a MOSFET? Dear students, which of the following is not a limitation? You just see this answer. Unipolar device. BJT is a, MOSFET is a unipolar device. Unipolar device means it is a majority carrier device. Majority carrier device. That is why switching frequency is fast. You know, in the case of MOSFET, due to the absence of minority carriers, switching speed is very fast in MOSFET. That means this point is an advantage. Okay. So that means this is not a limitation, this is an advantage. This point is advantage for MOSFET. So it is not a limitation. That means point is advantage means it is not limitation. So answer is option B. So clearly understand the question. They are asking which of the following statement is not a limitation. This point is advantage for MOSFET. Advantage means it is not a limitation. Disadvantage means limitation. All the remaining points are disadvantages. These are all the disadvantages. That is why they are limitations. They are wrong answers. So answer is option B. Okay. Now let us go back to the next question. Two BJTs are connected in parallel to share the total current of 25 amperes. The collector to emitter voltage of transistor 1 and 2 is 1.5 and 1.75 volts respectively. What is the difference in the emitter currents sharing by the two transistors when the current sharing series resistances are 0.25 ohms and 0.35 ohms respectively? Okay. So let me do this question here. Okay. Okay students, I will discuss the solution for this. Yes, two transistors are connected in parallel. Okay. This is the total current I is equal to 25 amperes. Okay. Now this current let it be I1 amperes, this current let it be I2 amperes. This is transistor T1, this is transistor T2, this is RE1, this is RE2. Okay. So now across these two voltage remains same. Okay. Now for the first transistor given, the voltage drop is 1.5 volts. This is 1.5 volts. For the second transistor 1.75 volts. 1.75 volts. So because they are connected in parallel, okay, because they are connected in parallel, the total voltage of both the branches must be same. What is the voltage of the first branch? First branch is I1 into RE1, I1 into RE1 plus 1.5 volts is equal to I2 into RE2. plus drop is 1.75 volts. So given RE1 is 0.25 ohms. This is 0.25 ohms. RE3 is equal to 0.35 ohms. Okay. So I can rewrite this one as RE1 is 0.25. So 0.25 into I1. This I2 is equal RE2 is 0.35 no. So minus 0.35 to I2 is equal to 1.75 minus 1.5, 0.25. So I can rewrite this one as 5 times I1 minus 7 times I2 is equal to 5. This is equation number 1. Second equation is sum of the currents I1 plus I2 is equal to 25 amperes. This is the second equation. So just to solve equations 1 and 2 and find the values of I1 and I2. So you will get I1 is equal to 15 amperes. I1 is equal to 15 amperes after solving the equation, and I2 is equal to 10 amperes. Now they are asking difference in sharing the currents. Difference in sharing the currents is difference I1 minus I2. So 15 minus 10. So difference in sharing the currents is 5 amperes. So answer for question number 6, option B is the right answer. Okay. So just go through this question, students. Answer is option B. Okay. For question number 6, 2 BJTs are connected in parallel. Option B is the right answer. Okay, students. Yes, please go through the solution. Then next question. Yeah, the typical upper ratings of power transistors. See, MOSFET is available at 500 to 600 volts. Current rating is about 40 amperes. Okay, so answer is option A. See, this is 800 volts, 1000 volts, 1200 volts. This is for IGBTs. Here, students, you see 800 volts, 1000 volts. So these ratings for BJTs and IGBTs. MOSFET is available only at 600 volts. Option A is the right answer for this question. Okay. So next one. Yeah, go through this question. It is from UJT relaxation oscillator. The firing frequency of a relaxation oscillator is varied by changing the value of charging resistance. What are the maximum and minimum values of R? So all the parameters are very clearly given here. Okay. Okay, I will give the solution for this. Okay, students. Now go through the solution for this question number 6. Question number 8. Question number 8, I hope, right? Yeah, question number 8. So UJT relaxation oscillator. UJT is operating as relaxation oscillator. Yes. Now this is our UJT, okay? This is a symbol for UJT. So here, when UJT is in the off state, when UJT is in the off state, just look here, when UJT is in the off state, the capacitor charges through this loop. Okay, when the capacitor charges through this loop, the capacitor voltage will increase, and when it reaches the peak point voltage, after reaching peak point voltage, UJT will turn on. So when UJT is off, the capacitor charges until it reaches the peak point voltage which is given in the question. That means the base voltage VBB should be greater than at least the drop of this resistance is given by peak point current to R. It should be at least greater, okay. This VBB value should be at least greater than or equal to peak point voltage into R, drop of this. Then when it reaches the peak point voltage, this is the peak point voltage, the drop of this is IP into R. It should be greater than IP into R plus peak point voltage. So from this I can say R should be less than or at the most equal to VBB minus peak point voltage by the peak point current. So R should be less than or equal to means is the maximum value. So R maximum is equal to VBB minus peak point voltage by peak point current. Now let us see the values here. VBB is given 20 volts, peak point voltage is 12 volts, peak point current is 0.65 milli. Just calculate this value, you will get 12.3 ohms. So this is the maximum resistance. So whatever I explained is when UJT is in the off state. And similarly, what happens when UJT starts conducting? See, after reaching the peak point voltage, then UJT starts conducting here. Okay, after reaching the peak point voltage, UJT starts conducting. After the UJT starts conducting, capacitor discharges through this loop till it reaches value voltage. So after the UJT starts conducting, capacitor discharges till it reaches value voltage. Capacitor discharges till it reaches value voltage. So in this case, when UJT starts conducting, here the valley current will be high. So just look here, the circuit diagram is like this for valley current. Okay, I will use blue color for this, like this. Okay, so here capacitor is discharging means you have to take the value voltage in the second mode. So when the capacitor is discharging, here VBB should be less than or at the most equal to here valley current into R, IV, drop of this valley current till it reaches value voltage VV. Okay, so from this I can write R should be greater than or equal to VBB minus value voltage by R. Okay, so I will use that formula here. So that is nothing but R minimum. R minimum is equal to VBB minus value voltage by valley current. So 20 volts minus the value voltage given is 1.5 volts. Valley current is 2 milli. Just simplify this one, you will get 9.25 kilo ohms. Okay, So maximum resistance is 12.3, minimum resistance is 9.25 kilo ohms. That is the range of this resistance. Range of this resistance. Minimum value is 9.25 kilo ohms. Maximum value is 12.3 kilo ohms. So please go through this. So what is the answer for this question? So answer is option A. Okay. For question number 8, option A is the right answer, students. Fine. Now the option A is the right answer for this. Now go through the next question. Please go through the next question. So in the question number 9, this is question number 9. The capacitor Cj, the value of reverse biased junction J2 of a thyristor is independent of the offstate voltage. Now the limit value of charging current to turn on the thyristor is 15 milliamperes. So given charging current is 15 milliamperes, dV by dt is 750 volt per microsecond. You know the charging current IC is equal to Cj into dV by dt. Okay. Now we have to calculate the value of capacitance from this expression. So therefore the capacitance, of course this is the minimum value, can be greater than this also. This is the minimum requirement. It should be capacitor current, charging current divided by dV by dt. The charging current is 15 milli, 15 into 10 to the power minus 3 by dV by dt is 750 volts per microseconds. Volts per microseconds. I think you will get 20 picofarad. I think. Please verify this, students. You are getting about 20 picofarad. So if you see the nearest answer, see which value is little bit greater than 20 pico. Answer should be little bit greater than 20 pico. So that means nearest answer which is greater than 20 pico is 50 picofarads. Option C is the right answer for this question. I hope everything is clear. See, dear students, all questions are direct questions, very easy questions here. Okay. So next, rectifiers, all these questions are single phase half wave controlled rectifier with resistive load is supplied from 250 volts 50 hertz AC source. When the average DC voltage is given, average DC voltage is 50% of maximum possible voltage, 50% of maximum possible voltage, that is given in the question. What is the firing angle of the thyristor and average DC voltage? So here it is a single phase half wave rectifier feeding resistive load. So here formula for average voltage is for resistive load single phase half wave Vm by 2 pi into 1 plus cos of alpha. So what is the maximum average voltage in this case? When alpha is equal to 0, maximum voltage is Vm by pi. Okay. See, this is the waveform you will get when alpha is equal to 0. Okay, we get maximum voltage. So here formula for average voltage is Vm by 2 pi to 1 plus cos alpha. 50% means half of Vm by pi. I hope it is clear. Half of Vm by pi. Half of Vm by pi. So to go through this one, this Vm by pi will cancel both the sides. 1 by 2 also will cancel both the sides. So alpha is equal to 90 here. So from this you can write alpha is equal to 90. That means if I increase alpha to 90 degrees, you will get only 50% of the voltage. That means just by looking the waveform you can answer. Firing angle should be 90 degrees. And what is the average voltage? Vm by pi. Calculate Vm by pi. RMS voltage is 230 volts, Vm is 230 root 2 by pi. So just calculate this value. So if you calculate this value, you will get 51.77, 51.77 volts. Okay. The answer is option C. Please go through this question, dear students. Very easy question. Nothing is there. Single phase half wave rectifier. When firing angle is 0, you will get half cycle of sine wave. When alpha reaches 90 degrees, you will get only half area. Half area means you will get only 50% of the DC voltage. Just by understanding the concept, you can say firing angle is 90 degrees. Okay, fine. Let us go back to the next question, students. Question number 11. Just see here. A single phase semi converter. Okay, single phase semi converter is supplied by 200 volts, 50 hertz, and it is connected with RLE load. Okay, load current is constant, ripple free. What is the average output current? Simple logic here. It is semi converter now. V naught is equal to E plus I naught into R. This is the basic equation for RLE load. Now single phase semi converter feeding high inductive load, formula for average voltage is Vm by pi into 1 plus cos alpha is equal to, what is the EMF here? 80 volts, plus what is the load current here? Given what is the average output current? Current we have to find. Resistance is 15. Okay, Vm is 220 root 2, 200 root 2 by pi 1 plus cos 90 degrees, firing angle is 90 degrees, is equal to 80 plus 15 into I naught. So calculate the value of I naught. Just simplify this. You will get 0.668 amperes. 0.668. So very easy question, students. 0.66, option C is the right answer. So for question number 11, option C is the right answer. Okay. Then go through the question number 12. Okay. A step down chopper has load resistance of 20 ohms with an input DC voltage of 100 volts. So there is a DC voltage switch. This is the step down chopper. Okay. Yes. Now when the switch is in the on state, the drop of the switch is 2 volts. See here, when the chopper switch is on, the drop of the switch is 2 volts during the on state. So if you draw the waveform for output voltage here, okay, until the switch is on, V naught is equal to Vs minus drop is 2 volts up to t on seconds. After that switch is off, so 0 voltage. Now from this figure, average voltage expression is Vs minus 2 volts for t on out of t seconds. So that is the expression for average voltage. So here duty ratio alpha is equal to capital D on by t, that is given 40%, 0.4 it is given. Okay, so I will write this question as, okay, Vs is 200 minus 2 to 0.4, okay. So that comes to 79.2 volts. That is the answer, 79.2 volts. But they did not give any answer 79.2. That means they might have neglected the drop. Nearby answer is 80 volts. You will get 80 volts if you neglect the drop. See, if you neglect the drop, you will get 80 volts. Okay? Take the nearest answer. So answer is option B. So next question. What is the expression for distortion factor in the case of inverters? Okay. In the case of inverters, the formula for distortion factor, if you see, I'll write down the formula for distortion factor in inverters. Summation of n is equal to 2, 3, 4 and so on up to infinity. Nth harmonic voltage by n whole square. Compare with fundamental voltage under root. Okay, first you take under root. Let us take under root here. Summation n is equal to 2, 4, 6 up to infinity. Nth harmonic voltage by n whole square under root divided by fundamental voltage. Okay, so that is the formula for distortion factor. So what is the right answer here? Please observe here. So option C is the right answer. See, option C is the right answer for question number 13. Okay, so actually there is another distortion factor. Okay, distortion factor means we consider fundamental by RMS. That is different distortion factor. That formula is not given here. This is a different one for distortion factor here. Okay, so next question. A separately excited DC motor is controlled by single phase full converter which is supplied from 440 volts 50 hertz supply. If the field circuit is also fed by single phase full converter with a firing angle 0 degrees, the firing angle of the armature converter is 30 degrees, load current is 20 amperes. What is the field current? They are asking here. Okay. Now I will answer the question here. Just please go through this. So we are having two full converters. This is the first full converter feeding a DC motor. First full converter feeding a DC motor. Firing angle is 30 degrees here. And we have field winding circuit which is also fed by another full converter. Okay. The field voltage and the field current. Firing angle of field side converter is 0 degrees. The full converter formula is 2 Vm by pi cos of alpha f. The firing angle of the field converter is 0 degrees. So you will get 2 Vm by pi cos 0 1. So calculate this value 2 into the peak voltage of AC supply is 440 root 2. This is 440 root 2 by pi because this voltage is 440 volts 50 hertz. That is why. If we calculate this, that is 396.139 volts. Now in this field winding resistance is given 140 ohms. Just simple question. Field current is equal to field winding voltage by field winding resistance. Field winding resistance. So 396.139 by 140 ohms. We calculate this 2.83 amperes. Okay, students. The answer is 2.83 amperes. So for this question, 2.83 option A is the right answer. Okay, students. Okay, option A is the right answer here for this question. The next question, consider the following statements regarding AC drives. AC drives require complicated control. This is wrong answer. Power converters used in AC drives again gave simple, both are almost same, wrong. VSI, CSI, AC voltage controllers use PWM inverters in variable speed control of induction motors. So 3 is the only right answer. So the only right answer is 3. Okay. So right students, with this we have completed all the video solutions for power electronics. I hope in power electrons all questions are very easy, right? Thank you, students.
Good evening, students. Now we will start with the solutions of power system. So myself and Murthy sir both will give the solutions. Around 13 questions came from for ESE prelims in electrical part. This is actually they are given the question in HVDC part. Which of the following is not a? Be careful. The question is actually asking about which statement is not correct. That is important. In that, control should be such that it should be require less reactive power. And one more is the DC current is constant, that is ripple free. Under steady state conditions, the valve must be fired symmetrically. This statement is wrong. Answer is actually, this is actually wrong one. Remaining all the statements are correct. So that answer for this one is C is the answer correct. Correct answer. C is the answer. Second part. Okay, right? Question number 3. This is related to static compensator. In this static condenser here, it is sensitive to transmission system harmonics. It has difficulty in operating with a very weak AC systems. Can be used for small amount of energy storage. So in this one, basically very weak AC system, whatever actually given here is it is preferable. Basically, very weak system is to make it more stable. Statcom is preferred. But what is given, this one is difficult is actually given. So that second statement is wrong. Remaining two statements are first and the third one is correct because it has internally consist of capacitance, so that it can able to store the energy. So the answer for this one is 1 and 3 is D is the answer for. Okay. Next, coming to the question number 22. So in this you can observe this type of the materials in regular class also we have discussed some of the material names actually. He has mixed both related to the US standards and European standard, both are mixed here. But how logically should answer for this question? First part is the meaning of this quad. Quad indicates 4 conductors are there and the triple indicates 3 conductors are there. So basically the quad conductors having more radius, so that automatically whatever the surge impedance loading, you know the SIL formula. For the case of SIL, your writing is voltage square by surge impedance is ZS, or this is actually current is Vs square into under root of what? ZS is given by under root of L by. Whenever 4 in quad conductors have automatically the inductance will be less. This is SIL will be, is one part. Compared to if I am using a triple conductors, I am using, for example, this is 3 bundle conductors are using, and it's of twin nothing but 2 conductors. Compared to the 3 conductors, 4 conductors and 2 conductors, this is actually what you can call as quad. This one is going by triple. This is of twin. So which one is having very less value of inductance is quad is having very less value of inductance. SIL will be. Next one is triple. Next one is twin. So accordingly, you can think of here. In this one is also you will get confusion here P and R. In this one actually the P is this is actually having highest one, and next order for this one is of 647. That you have to remember some parameters here. Next one is a triple. Triple is having a 605. Twin is actually having the last one is 5. That accordingly you can put these answers are given by 3, 4, 1, 2. This answer is what? A is the answer for. Okay. This is for the question number 22. Okay. Next one. So in the case of critical disruptive voltage, what we know, actually the formula you know that tan of D by R. So what is asking in this particular part is the maximum critical disruptive voltage is asking.
So, to get the maximum critical disruptive voltage means you have to make this dVc by dr should be 0. That is possible if you do the derivative with respect to this r by r equal to what E. From this you can take r equal to what, small r is fine, r by E. How much is the radius I have to maintain? This is a similar model we have done case of cables also, where you are getting most economic size of the conductor. Same logic, same almost all same equation you can use, but it is actually, that is in that part we have to use the parameters of a denominator term actually. Here it is actually a numerator part. Okay, so that answer for this question is left d by r. No, this is actually I have taken as r by r. This is actually taken off d by r. Sorry, this one is that I have used r here. Is d by. So that answer for this one is C is the correct one. Now coming 25th question. So in the case of faults, actually we have discussed maximum number of faults are occurring in case of overhead lines is 50%. Normally practical case is around 70%. As per this question you can observe here. Next one is underground cable, these are of 10%. Transformers is of 9% and generators is of what, 7%. So accordingly you can put this for this question 2143. No? 2143. This is actually comes in P is the answer for. Okay, related to the remaining questions, Murthy sir will do the solutions. Thank you. We'll meet in the mains batch. Okay.
Hi. I'll carry the further questions. Okay, so here it is the next question is that one is for a 735 kV line with a fault current of 4 kilo amperes. What is the arc resistance assuming the no resistance in the ground return path? So it is a simple question that is being. So the answer is that one is this is nothing but 735 divided by how much it is being the 4 kilo amperes. So 4. So it is in the kilo. It is in the kilo. Therefore, the answer will be coming as 183.75 is the answer. It is. It is a simple calculation. 735. Okay, it's a simple calculation. 183.75 ohms is the answer. Simple calculation because the arc resistance it is said that one is there is no resistance in the ground or return path. That is the reason what is happening is through from that conductor to the ground through the path of faulty path. What is the resistance is there? The resistance through the faulty path can be called as a arc resistance. Next question. So considering the following statements regarding the static relays compared with the electromagnetic relays, okay, which one of the statements are being correct? It is. So what is the answer that what you can give in this case is in static relays frequent operations cause the deterioration, and in static relays there is no quick resetting and absence of overshoot. Static relays are sensitive to the voltage transients. This is the right statement. Static, because the thing is that one is the transients electronic equipment could not be able to resist the transients. So therefore the 3 is the right answer. So therefore first selectivity that you have to take is the 3. Where frequent operations cause the deterioration. Yes, the steady state is being required. So that is the reason what is happening, the combination of the 1 and 3 to be taken. So therefore D is the right answer. Next is that one is what is the maximum value of the restriking voltage across the contacts of the circuit breaker that together. So this is VR maximum equal to 2 Vm. So this is equals to 2 into Vm means what is happening, root 2 into this is how much it is 132 kV you leave it and divided by root 3, because the thing is that this voltage has been given between the line to line, but the restriking voltage, recovery voltage that you need to calculate between the contacts. Between the contacts means they come in phase. So that is the reason all these calculations you have to take it per phase. So thereby the answer for this one is equals to 215.56. This is the right answer. A simple calculation. Next. Considering the following statements regarding the radial distribution system. So here the 3 things has been given. A distributor far away from the substation is highly loaded. The loading, we can't say that one is a location, that depends upon the loading conditions. Severe voltage variation to the consumer nearest to the substation due to load variations. No, actually thing is that one is near to that substation, the voltage will be constant. If it is the far away, then what is happening is because of the load variations, the voltage change may be there itself. Consumers are dependent on a single feeder and a single distributor, and the fault on either of them causes interruption of the supply to all the consumers. This is the most appropriate one. So that is the reason what is happening is you need to consider this is. Regarding it is the load flow analysis, generator bus, load bus and slack bus has been given. We know one thing is that one is at the generator bus, what are being specified? P and V are specified. P and V are specified means what is happening is which are unknown. So, reactive power and delta, where it is reactive power and load angle. This is the answer for this one. And at the load bus, what is happening is, you know, P and Q are specified. That means V and delta are not known to us. That means voltage magnitude and S angle, this one. And at the slack bus, actually the problem is that one is at the slack bus, the specification of the V and delta is being there, but there is no point of unspecified P and Q. But anyhow, according to the question, this is the answer for this. Okay, so this is the, that's all for this power system. Thank you very much.
Thank you. We'll meet.
Okay, we
mains
will meet
batch.
in the
Mains
further
batch.
classes
Okay.
and in future.
Thank you.
Okay, all the best.
So, hi dear students, now we are going to deal about analog electronics in electrical engineering. So, myself Adada Rajkumar, my colleague Iftikhar sir, we are both going to deal analog electronics. So, first I think we got so many questions in electrical, I think
16 questions have
16
come.
questions have, and they are not, some are tricky questions.
Yes, some
I
are
think.
difficult questions and
Yeah.
some are very easy. So
Some are
like,
confusing.
confusing.
In electrical engineering. Anyway, we will discuss that questions. You can check your answers. So, first half of the questions I will complete. Remaining, my friend Iftikhar sir will come.
Yes, sir.
Thank you, sir. Question number 6 we are dealing now. Question number 6. two BJTs are connected in parallel sharing the total current 25 amperes. The collector to emitter voltage of T1 T2 are some voltage is given 1.5 volts and 1.75 volts respectively. What is the difference in the emitter currents sharing by the two transistors when the current sharing series resistor RE1 and RE2 is? That means first you have to represent a model for this. If you write a model, you can understand how to solve the question. Let me show you a model here. There are two transistors like this with some resistance RE1. Parallelly, there is one more resistance with one more transistor. This are connected. Current going is 25 amperes. Current is going to the two transistors. They are connected in parallel. So this is the framework. If you can do, you can understand how to deal the question. These two transistors are in parallel now, okay, and below they have given RE1 and RE2 resistor. Now, if the current is here I1, if you take this side current is I2, there are two currents are providing to the two transistors 25 ampere. The question what is asking is, what is the difference between these two currents is I1 minus I2 will be how much? So, to find out this, what is my simple logic here is, the same I1 will flow here, same I2 will flow, because if beta is considered to be large, IC is equal to IE concept you can apply. So, same current you can take. Now, we will apply parallel concept according to the networks. If this side potential, if you take 1.5 EC voltage, this side potential is 1.75. So, both sides you are having parallel voltage. Now, you can have this total branch parallel to this branch. So, I1 into 1.5, I1 into RE1 plus 1.5 equal to I2 into RE2 plus 1.75. Just I made both the branches parallel. This side total drop should be equal to other side second transistor drop. If you can do like this, and if you make this I2 as 25 amperes minus I1, replace this, because according to the diagram I1 plus I2 is 25 amperes. So, I1 I2 can be replaced as 25 minus I1. If you do all these things, we will get I1 value from this. What is the I1 they are getting from this equation? I got I1 as 15 amperes. Then I2 if you want is 25 minus I1 is 25 minus 15 will be around 10 amperes. So, I1 I2 is completed this circuit. Now, you can take the difference of I1 minus I2, I1 minus I2, that is 15 minus 10, which is 5 amperes. So, this will be the correct answer. So, I am expecting option B with the correct answer for this question. Okay. So, it's a very interesting question, even ESE, wonderful question, good. So, B is the correct option for this question. Okay. Yeah. We will go to the next question. So, the next question is question number 46, it's an analog question again. Consider the following characteristics of regarding ideal operational amplifier. Talking about an ideal operational amplifier, an infinite output impedance and a zero input impedance, telling reverse answer. It will have infinite input impedance, output impedance will be 0. So, it is looking wrong statement. The op amp must have an extremely high inherent voltage gain. Okay, this is correct. For any ideal op amp, the voltage gain should be high. Zero sleeve rate is the wrong statement. Sleeve rate for an ideal op amp is infinite. Okay. So, statement 1, statement 3 are looking wrong, statement 2 is correct. But according to him, what he wants, which of the above characteristics are correct? He wants the correct answer. So, only option 2 is correct answer. So, I can take option C is correct answer. Only 2 is statement is correct. First statement and statement number 3 is wrong. Okay. We will proceed to the next question. So, one more question you can see here, an inverting amplifier using 741 IC. The popular IC in op amps is 741 IC, must have a flat response up to 40 kilo, okay, which is F naught they have given maximum frequency. So, the gain of the amplifier is 10. What is the maximum peak to peak input signal can be applied without distorting the output? Okay. So, if you see this question, we have a formula for sleeve rate question. It is related to sleeve rate. We have a formula here, that is ACL to VM to omega max, okay, total divided by 10 power 6 less than or equal to. So, if you apply this formula, okay, sleeve rate question, but in this problem they have not given any sleeve rate value. That is the only thing student will get confusion. ESE exam sometimes related to the value of 741 IC, that value you have to apply and we have to see the checking them. Somewhat difficult actually. So, if you say 741 IC, the sleeve rate typical value range between 0.5 volt per microsecond to 1 volt per microsecond. So, I checked for 0.5 volt per microsecond and 1 volt per microsecond, but if I assume it has 0.5 volts per microsecond, the option is matching in the problem. So, according to the 741 IC op amp, sleeve rate they are assuming it as 0.5 volt per microsecond. This is only assumption we have taken. Select the answer. So, if you assume like that, the range 0.5 volt per microsecond, generally 0.5 to 1 we can expect between, but 0.5 I have taken. If you take 0.5 volts per microsecond, so that Vm you have to calculate first. Vm is equal to sleeve rate to 10 power 6 divided by ACL into omega max. Okay. If you solve this, Vm I am getting around 0.199 volt. So, this is the value I am getting, Vm value, because omega naught you can write as 2 pi f naught. F naught is given here 40 kHz, you can substitute it and get the answer. But it is not asking Vm here, in the question they are asking peak to peak value. So, peak to peak is nothing but to peak, put nothing but 2 Vm you can take. So, the answer is 2 into 0.199. So, you can take this answer as a option for this question. I am expecting the answer is coming 0.398 volts. 0.398 volts. So, option A will be the correct answer. But this type of question, the students, a basic student, they do not know that range, they cannot attempt this. Okay? Because in general, we know the range, that is why I have taken and I solved it, matching with the 0.398 volts. Okay? So, the next question, question number 50 is the next analog question. What is the value of capacitance to use in a capacitor filter? It is asking about filter question, and operating with standard aircraft power frequency of 400 Hz, the ripple factor is 10% of a load of 500 volts. Must know the formula of ripple factor. Ripple factor for full wave rectifier, it is 1 by 4 root 3 RL into F into, this is the formula of ripple factor for full wave rectifier. So, he is asking the C value, 1 by 4 root 3 to RL into F to ripple factor. Okay. If you substitute the given data here, it is 1 by 4 root 3, RL he has given 500, F naught is 400 H into ripple factor is at 10%, ripple factor is 10% for the load of 500 ohm, 10%, nothing but 0.1. 10 by 100, it is a 0.1 I have. So, if you solve this problem, we are expecting the total value is coming around total value is coming around 7.22 microfarads. The ripple factor is 10% for a load of 500 ohms. Okay, for a load of 500 ohms. So we are getting around 7.22 microfarads coming answer, but in the option if you see they have given 72.2 microfarads. So there is some decimal not matching with this calculation. Okay, so we can expect 7.22 microfarad with the correct answer. There is some mistake in the option we can expect. Okay, this is about question number 50. So I am not selecting any option because the option is not matching with my calculation. This 7.22 microfarads is coming here. Okay, next question we will see. So question number 50. Question number 51, not related to analog question. Question number 79. Question number 79 we will see. Consider the following statements regarding applications of PN junction diode. It is asking the applications. It is used as a switch in DC power supply statement. It is used as a rectifier in voltage stabilization circuit. Statement is correct because it will work as a switch, but the diode works as DC power, but it uses as a rectifier in voltage stabilization circuits. It is used as a rectifiers in voltage stabilization circuit. That is the second statement. It is used as a signal diode in communication circuit. Okay. Now the point is, first statement is correct, used as a signal diode, communication circuits is correct. But if you see in the options, they have given only two options. That means here there is something we have to understand. It is used as a rectifier in voltage stabilization circuit, they are telling. But in voltage stabilization circuit, the diode which we use is not a PN junction diode, we use Zener diode. So according to that, you can just cancel this statement. So first and 3 are correct, we can take. Okay, 1 and 3. So option D we can take it as a correct answer. Okay, option D you can. The next question is also statement based questions are coming, more questions. Consider the following statements regarding transistors. They can be made to oscillate very small power consumption. So generally they can work like an oscillators, low power consumption. Statement is they cannot sustain mechanical shock. Generally if you compare with vacuum tube, semiconductor devices are made with semiconductors, where for shocks also they can withstand for that. So this is a wrong statement. Their applications is limited up to few mega cycles. Generally we go for mega hedges, transistors work up to mega. So this is correct statement. So 1 and 3 are looking good. Second statement is not correct. So for question number 80, option D will be the correct answer. 1 and 3 are correct answers for this question. Okay. And one more question I will deal. So this is question number 81 we are dealing. Field effect transistor operates with a drain current of 100 milliamperes and a gate source bias of -1. The device has a dynamic forward transconductance of 0.25 Siemens. If the bias voltage decreases to -1.5, what is the new value of drain current? It is asking the new value of drain current. Then we can use a formula, Gm is equal to del Id by del V. You can apply this form. Change in the drain current by change in the gate to source voltage, which is nothing but Id2 minus Id1 divided by Vgs2 minus Vgs1. Gm already has given here in the problem is 0.25 equal to Id2 is unknown minus Id1 is 100 milliamp divided by Vgs2 is minus 1.2 minus of minus 1 volt. So ID2 you can solve in this problem. So ID2 I am expecting for this question is coming 50 milliamp. 50 milliamperes. So option A will be the correct answer for this. Okay. So these are the certain questions have been completed. The remaining questions will be completed by my colleague Iftikhar sir. Okay, I am handovering to Iftikhar sir. Thank you, sir. So you can take this page.
Thank you, Rajkumar sir.
Yeah, yeah. Thank you.
Dear students, I will be discussing the remaining questions, remaining 8 questions that have come in today's exam. The next question is about match the following. Okay, now this is a question that you will be able to answer if you have done some lab work in your engineering. Okay, you did some experiments on BJT in the laboratory, you will be able to remember these things. Okay, these are transistor numbers BC108. Now this BC series, it is used for mainly audio frequencies. BC series transistor, it will be used for audio frequency small signal amplifier. तो अगर आप ऑप्शन देखेंगे तो P वाला जो ट्रांजिस्टर है it will match with general purpose small signal amplifier. Okay, P will match with 2, and BF series, that BF series is used for radio frequency or high frequency amplification. Okay, radio frequency or high frequency amplification, I mean आपका Q ऑप्शन मैच करेगा with radio frequency amplifier, यानी कि Q matching with 2, Q matching with 4, Q4. Okay, then there are 2 more transistors, 2N3904. This will be used mainly as a switching purpose. It will be used as a switch. It is an NPN transistor which will be used mainly as a switch. Okay, so 2N3904, it matches with switching. So आपका R transistor matching with 1, and then remaining will be this 2N3055 transistor. It will be used in power amplifiers. Okay, this last transistor used in power amplifiers, so वो match हो जाएगा with low frequency power. Okay, that S matching with 3. So आपके option बनेंगे 2413. If you look here, 2413, I am saying this in D option. So the correct answer for this question is option D. Okay, and this type of questions require some practical knowledge of transistors. Okay, next we have this particular question. It is based on PNP transistor. Okay, PNP transistor, you know the structure of PNP transistor, where emitter will be P type, base N type, and collector P type. Okay, your emitter, base, and collector. Now let us read the statements. Base collector junction is reverse biased, 2 holes in the base region and electrons in the collector region. This is actually a wrong statement. Reverse biasing will actually prevent, अगर आप base collector junction को reverse bias करेंगे तो it will prevent the movement of electrons from base to collector and movement of holes from collector to base. Okay, लेकिन statement में क्या कहा गया है, this is reverse biased, 2 holes in the base, जो कि गलत है. It should be electrons in the base. Reverse bias prevent करेगा electrons को, electrons of the base region. Okay, electrons of the base cannot go into collector, and similarly holes of the collector cannot go into base region. So in that way statement 1 will be wrong. Then statement 2, base region is very thin and it is lightly doped with electrons. That is correct. In any BJT we keep base region lightly doped. Okay, and it will be narrow also. Base region we keep narrow to reduce number of recombinations. So statement 2 यहाँ पर सही है बेटा. Then statement 3, a large portion of the electrons in the base region cross the base collector junction into the collector, creating a collector current. In PNP transistor actually holes travel, right? You know the basic operation of BJT. Holes travel from emitter into base and those holes move into collector, and that constitutes collector current. So it should be hole movement into the collector, it will form collector current. लेकिन ऑप्शन में क्या कहा गया है स्टेटमेंट में, इट इज सेइंग इलेक्ट्रॉन्स क्रॉस, जो कि गलत है बेटा. यहाँ पर होल्स होना चाहिए, होल्स विल क्रॉस. ओके, होल्स मूव करेंगे फ्रॉम एमिटर इनटू बेस and then from base into collector, and that becomes your collector current. So it should be hole movement which constitutes collector current, not electron movement. Statement 3 यहाँ पर गलत है. So in this क्वेश्चन स्टेटमेंट 2 सही है बेटा, और हमें यहाँ पर करेक्ट स्टेटमेंट ही आइडेंटिफाई करना था, तो इसका आंसर होगा ऑप्शन ए. ओके, फॉर दिस क्वेश्चन you can take answer as option A. These are like theoretical questions. Then let us look at this one. This is very easy. Most of you must have done it correctly. यहाँ पर हमें एम्पलीफिकेशन फैक्टर दिया हुआ है, यानी कि म्यू इक्वल टू 80. ओके, म्यू इक्वल टू 80 एंड ट्रांस कंडक्टेंस गिवन है 200 माइक्रो. अगर आप इसको मिली में कन्वर्ट करेंगे इट विल बिकम 0.2 मिली सीमेंस. Then we know this formula, amplification factor, it is a product of transconductance and dynamic drain resistance. In case of FET, this product of transconductance and dynamic drain resistance, that product is known as amplification factor, और उसको हम डिनोट करते हैं विद सिंबल म्यू. अब हमें यहाँ पर कैलकुलेट करना है बेटा RD, डायनामिक ड्रेन रेजिस्टेंस. इट विल बी म्यू डिवाइडेड बाई जी, यानी कि 80 डिवाइडेड बाई 0.2 मिली. मैंने जीएम का वैल्यू मिली में लिखा है. आई विल गेट रेजिस्टेंस इन किलो ओम्स. अगर आप ये कैलकुलेट करेंगे बेटा तो इट विल बी 400 किलो ओम. So in this problem the dynamic drain resistance how much? 400 kilo ohm. So we can take answer as option C. Okay, correct answer is option C. It was a very easy question and you might have done it correctly. Next, this is about there is no need of a driver stage if FET is used as power amplifier instead of BJT. This is a question on the tougher side. Okay, अगर आपको थोड़ा सा पावर एम्पलीफायर का आइडिया होगा देन यू कैन आंसर दिस. अगर हम FET को यूज करेंगे इन ए पावर एम्पलीफायर देन वी डोंट नीड ड्राइवर स्टेज, एंड दैट रीजन इज इन FET gate current will be 0 and FET is a voltage controlled device. FETs are voltage controlled devices, so we can directly connect a voltage source to as input to FET, right? That voltage source can be connected directly without any maybe a buffer or driver stage in between. Okay, हम voltage source को directly connect कर सकते हैं to the FET. So the main reason for this concept is FET is a voltage controlled device. It doesn't need any current. Okay, gate current of FET will be 0 and we call FET as a voltage controlled device. So this property, FET essentially a voltage control or voltage operated device. This is the reason that we don't need a driver stage when we make a FET power amplifier. Okay, in BJT power amplifier we need one driver stage also, just to match impedances. It is that type of concept. In BJT amplifier we require a driver stage, but FET power amplifier we don't need a driver stage. Normally driver stage will be connected before power amplifier, remember. Okay, so इस वाले क्वेश्चन का आंसर होगा ऑप्शन डी. नेक्स्ट, match the following regarding field effect transistor amplifiers. Okay, this is based on properties of common source, common drain and common gate. Common source amplifier is used mainly as a audio frequency and radio frequency amplifier. Common source configuration used mainly as a audio frequency amplifier and sometimes it is also used as radio frequency amplifier. तो यहाँ पर P match करेगा बेटा with 2, right? And common drain will be used for impedance matching as a buffer. Common drain will be used as a buffer for impedance matching. So Q match करेगा with 1, and common gate will be used for radio frequency and very high frequency amplifiers. Normally common gate works well at high frequencies. Okay, in high frequency amplification we can prefer common gate amplifier. So R match करेगा with 3. So this will be like 2 1 3. If you look at the options 2 1 3 आपको option A में दिखाई देगा. So this question correct answer is option A. Then next question is again similar. It is about BJT amplifier. Okay, common emitter, common collector, common base. अब इसका भी concept same ही रहेगा. Okay, common emitter will be used as a general purpose audio frequency and radio frequency amplifier. P matches with 3. Remember, common emitter and common source, they are similar. Okay. Common collector will be used for impedance matching, just like common drain. Common collector and common drain, they are similar amplifiers. They are used for impedance matching as a buffer. And common base amplifier को हम use करेंगे for radio frequency and very high frequency amplifier. Common base is same as common gate amplifier, remember. So common base will be used for radio frequency and very high frequency amplification. तो R मैच करेगा बेटा with 1, तो इसका ऑप्शन होगा 3 to 1. 3 to 1 आपको दिखेगा ऑप्शन सी में, राइट. तो दिस क्वेश्चन क्वेश्चन नंबर 87, इसका आंसर होगा बेटा ऑप्शन सी. Then we have one more question. It is again about common emitter, common collector and common base. Okay, हमें यहाँ पर बताना है कौन से स्टेटमेंट करेक्ट हैं. कॉमन एमीटर एम्पलीफायर हैज हाई गेन एंड नैरो बैंडविड्थ. कॉमन एमीटर को प्रॉपर वोल्टेज गेन, हाई करंट गेन, but the drawback is it will have narrow bandwidth, and that is because of Miller effect. Okay, in common emitter amplifier there is a Miller effect problem. Okay, that Miller effect, it will increase input capacitance of common emitter, and because of that bandwidth will decrease. Common emitter का drawback होता है narrow bandwidth. Okay, gain will be high, current gain, voltage gain दोनों high होंगे, but bandwidth will be narrow. तो statement 1 correct है. Common collector has lower gain but a larger bandwidth. कॉमन कलेक्टर का वोल्टेज गेन 1 के बराबर होता है. ओके, एंड बैंडविड्थ विल बी मोर एज कंपेयर टू कॉमन एमीटर. कॉमन कलेक्टर विल गिव यू हायर बैंडविड्थ बट इट्स वोल्टेज गेन विल बी इक्वल टू 1. तो स्टेटमेंट 2 करेक्ट है. स्टेटमेंट 3, कॉमन बेस हैज हायर गेन एंड हायर बैंडविड्थ. लार्ज बैंडविड्थ सही है बेटा, बट हायर गेन रॉन्ग होगा क्योंकि कॉमन बेस का वोल्टेज गेन तो हाई है बट करंट गेन विल बी 1. ओके, तो नॉर्मली जब हम गेन की बात करेंगे तो हमें दोनों गेन देखनी होती है, करंट गेन एज वेल एज वोल्टेज गेन. इन कॉमन बेस एम्पलीफायर नो डाउट वोल्टेज गेन हाई है बट करंट गेन विल बी इक्वल टू 1. ओके, सो इन दैट वे स्टेटमेंट 3 विल बी रॉन्ग. सो दिस क्वेश्चन करेक्ट ऑप्शंस आर 1 and 2. You can take answer as D. Okay, option D will be correct here. Then we have one more question about common collector. There are so many questions from amplifier topic, okay, and these are simple theory questions. In a common collector amplifier, impedance between base and emitter is magnified. You know, common emitter का input resistance कुछ इस तरह से हम calculate करते हैं, R pi plus 1 plus beta into RE. That higher input resistance, it happens because of negative feedback. Okay, if you remember the circuit of common collector, in common collector there will be one resistor RE, okay, which provides negative feedback. This resistor RE, it will provide negative feedback. It actually provides voltage series feedback. Know this from feedback concept. In common collector amplifier, resistor RE, it provides voltage series feedback, and voltage series feedback, it causes increase in input impedance. Okay, so this question correct answer will be negative feedback. Input impedance high because of voltage series negative feedback. Okay, and there is one more question about Colpitt's oscillator. Okay, सारे concepts cover हुए हैं बेटा. पिछला क्वेश्चन फीडबैक से रिलेटेड था एंड दिस इज बेस्ड ऑन ऑसिलेटर, कॉल्पिट्स ऑसिलेटर. इन कॉल्पिट्स ऑसिलेटर द अमाउंट ऑफ फीडबैक इज कंट्रोल बाय, अब ये सबको पता है इन कॉल्पिट्स ऑसिलेटर मिनिमम गेन का फॉर्मूला कुछ इस तरह से होता है, x2 डिवाइडेड बाय x1. दैट x2 बाय x1, अगर आप x2 x1 पुट करेंगे, x2 इज लाइक रिएक्टेंस ऑफ कैपेसिटर्स दैट वी यूज इन कॉल्पिट्स ऑसिलेटर, लाइक दिस. C1 we connect to the input terminal and capacitor C2 we connect to the output terminal. Everybody knows circuit of Colpitt's oscillator. We connect two capacitors and one inductor, right? C1 connected to input side, C2 connected to output side. So here x1 x2 are reactances of C1 C2. I have written their magnitude. Okay, so this will become C1 by C2, C1 upon. Then we know condition in oscillator, A into beta equal to 1. Right, in every oscillator gain multiplied by feedback factor, that ratio will be equal to 1, right? तो यहाँ से हम कह सकते हैं feedback factor equal to 1 divided by A, and what will be 1 by A? It will become 2 by C1. तो आप clearly देख सकते हैं बेटा, feedback factor beta, it is equal to the ratio of capacitance. Okay, so feedback or amount of feedback, it depends on the ratio of capacitors. का आंसर होगा option C. Okay, question number 90, correct answer is option C. I think these were the questions that came from analog. Totally around 16 questions appeared, and as we told in the beginning, some questions were on the difficult side, no doubt, but some questions were very easy, right? Like the questions that I did just now, they were on the easiest side. So hope you all have done proper in analog section. Okay, my best wishes to all of you for your future dreams and aspirations. Okay, God bless you all.
Yeah, good evening all, and you see communication systems questions for electrical this year, 6 questions given, and except one, I think all the remaining questions are easy questions. See them. And if you see, this is about the short noise current. So the emission current, or it is also called as the direct current, and is denote with IDC, direct current or emission current. What is the RMS current? We have to find out. RMS value of short noise means RMS value of noise current for 10 megahertz. This is the RMS short noise current is equals to root over 2 I delta. ये एक formula है. If you go through the previous ESE prelims questions, if you go through, so you will come across this formula. So if you substitute, it is 2 and Q is the electron charge. This is 1.6 power minus 19. This is coulombs. It is 1.6 into power minus. And the IDC, that is given 12.5. Okay, delta F is 10 into 10 power 16. So they should not deal with the ESE prelims. So this what we can do, because without calci we can't do all this. This is such okay mathematical questions in the ESE prelims, but we can't help it. What we can do? Okay. If you do this, you come to 2 microamperes. So this question to nahi hoga, means exam mein doing all these computations. This is quite unfortunate. So the remaining questions are easy questions. See this C is given unmodulated AM power means PC is, and the percentage of modulation is it is, and you need to find out the total power radiated. That is a direct formula. Is PC times 2 1 plus square by 2. So substitute and it comes to be 10.45 kilowatt. Option B will be correct. See this question here. So which of the following statements correct? We have to check. Okay, and here again the process of demodulation is complex in AM compared to FM is incorrect. Okay, because AM demodulation is the most simplest demodulation. FM broadcasting, the stereophonic transmission is possible. Yes, the audio transmission, stereophonic transmission, audio transmission, that is possible in FM. AM broadcasting system has poor noise performance. Yes, that is okay. The noise performance AM is very less. FM ka noise performance acha hoga. So which statements are correct is 2, so this option A will be correct. And if you see the signal voltage is given, I am denoting this S, and the noise voltage denoting, I have to find SNR, signal to noise ratio in number. In number means dB में नहीं है, just number में find करना है. So SNR means it is signal to noise power ratio. You need to understand signal to noise power ratio.
Vs upon P. So it is voltages में है तो S square upon Vn square, because power is proportional to voltage square. So it is Vs upon Vn whole square. This S is 0.9 upon 0.267 square करना है, so it comes to be 11.95. Option D will be correct. And if you see, this is about sampling. This you will come across in signals and systems also, and this is related to sampling. The sampling you will see in communication also. If you see the previous ESE prelims questions, you will come across this. We have to match here the natural sampling. The natural sampling may just we multiply the message signal. The message signal we multiply with the pulsed signal. Multiply with the pulsed signal. If you do this multiplication, so that is comes under the natural sampling. So if you see the resultant signal we expect like this. Okay, so where the amplitude of the pulses are going to be varied like this. Okay, this is something like, this is just looking like we have to select the signal in regular intervals. We have to select the signal in the regular intervals. So it is a kind of okay, the switching I can say, or it is a kind of chopping I can say. Just give this to a on-off device. Okay, on for in the respective intervals, on in the respective intervals, and off in the remaining intervals. So this is the resultant signal is going to be. So this is a kind of switching, or it is a kind of chopping I can say. The multiplication or chopping is okay. This is P will be 3. Flat top sampling. Flat top sampling may, if you see the resultant sample signal, so the amplitude of the pulses they will made flat like this. Okay, the amplitude of the pulses will be made flat like this. So to for this definitely we need a sample and hold device. We need to sample and we have to hold that value. In that specific interval. So for that sample and hold is required. So Q will be 1. The ideal sampling, this is also called as impulse sampling, where we will multiply the signal with the impulse sequence. So it uses only multiplication, not switching. So it is only multiplication. So 3, 1, 2. This is 3, 1, 2 means C will be correct here. And this is actually a general question. Which of the following is used to detect burst errors? So this is out of scope to electrical students. For electronic students के लिए ये काफ़ी easy है. This is within the syllabus for electronic students, but unfortunately they're given for electrical students. Burst errors means continuous errors. So to detect the continuous errors, okay, in communication, cyclic redundancy check, this error detection method is actually used. So the remaining are actually, these are not error detection methods basically. Okay, so this is pulse code checking. ऐसा कोई term ही नहीं होता है. This is actually pulse code modulation बोल के एक term होता है. And bit stuffing, bit spoofing, this is networks, computer networks का related terms है. And here these terms are not related to error detection. This first term is only related to error detection, and the option A is going to be correct. Okay, so all the very best guys. Thank you very much.
Dear students, greetings of the day. Murli, Mains faculty. I'll be dealing transformers and induction questions of this ESE 2020. Let us start with question number 18. A 0.5 HP 6-pole induction motor is excited by a 3-phase 6-stage source. If the full load speed is 1140 RPM, what is the percentage of slip? Percentage slip. (200). So as it is mentioned 6-pole, 60 Hertz. Pole 60 Hertz. Synchronous speed is Ns is equal to 120 1200 RPM. Given speed is 1140. So percentage slip is 1200 minus 1140 by 1200. 200. 5%. Question number 69. A transformer on no load has a core loss 50 watts, draws a current of 2 amperes and has an induced EMF of 230 volts. What is the core loss current? Core loss current means IC. IC formula is not cos phi naught. We have a data. This is I naught. This is W naught. And this you can take it as V. Induced voltage is equal to supply voltage. On no load we can take neglecting the drop. So equal to not cos phi naught. From this cos phi naught is equal to not by V into, by substituting W naught 50 watts, by substituting 230 volt and by substituting here 2 amperes, get cos phi naught value. .108. So IC equal to I naught 2 amperes 0.108. This will be 0.216. Next question. A 500 kVA transformer has an efficiency 95% at full load and also means 95% at 60% full load, both at unity power factor. Separate out the losses of the transformer means how to find out iron loss and copper loss. As per the question, Pi iron loss and Pc is copper loss. Simple. This is the rating of the transformer. Efficiency format. Efficiency at a given load, at a given power factor is fraction of load N to kVA rating, volt ampere rating into power factor by same output by output volt ampere rating into power factor plus Pi plus N square PCU. If PC is copper loss as per the question terminology, N square, because copper loss depends on the load, square of the load, N square. From this we can write two equations. First equation is for full load, unity power factor. Second equation is for 60% full load, unity power factor. Now efficiency value is 0.95, 95% at full load, unity power factor. So full load means N is 1, unity power factor means power factor is 1, kVA rating I will keep, so that losses will come in kilowatts. So 1 into 500 into 1 by 1 into 500 into 1 plus Pi plus Pc. 1 square Pc becomes Pc simply. This is equation number 1. You can frame equation number 2 because efficiency value is same for 60% full load given in the question. So 0.95 equal to, in place of N we can keep 0.6, 500 to unity power factor by 0.6, 500 into unity power factor plus Pi plus N square. Here N is 0.6, 60% means N is 0.6, 0.6 square Pc. This is equation number 2. Two equations, two unknowns, Pi and Pc. By solving 1 and 2, we get Pi, Pc values. Next question, 240 volt by 120 volt 12 kVA 2 winding transformer has a full load unity power factor efficiency of 96.2%. It is connected as an auto transformer to feed a load at 360 volts. This is important. You can connect a 2 winding transformer as an auto transformer in 4 different ways: HV common, additive polarity, subtractive polarity; LV common, additive polarity, subtractive polarity. Step up, step down modes are same, so totally we can segregate into 4 groups actually. In these 4 groups, output 360 volt will come for 2 things. HV common additive polarity will give you 360. LV common additive polarity also will give you 360. But here the fact is, both connections won't give you the same rating. Let us find out both at a time simultaneously. In a simple way, first let us deal HV common additive polarity, which is the most popular or which gives the highest rating. That connection will. For that, the 2 winding transformer what we are talking, I am putting here current ratings, because when we reconnect as an auto transformer, current ratings should not violate. Voltage ratings as well as current ratings should not violate. So first let us see what is the current rating of 240 volt side and what is the current rating of 120 volt side, because the rating is given 12 kVA. $12,000 by 240 will be 50 ampere. 12,000 by 120 will be 100 ampere. When you reconnect this as an auto transformer, don't violate the current ratings. So first connection, let us take it like this: HV common, additive polarity. This is first connection. Second connection is LV common, additive polarity. Both will give output 360 volts. That's why I am taking both at a time. So first I want to show you HV common. Additive polarity I am showing with dots. This is 240 volt winding. This is 120 volt winding. Both are in series, both are in additive polarity mode. So obviously the output voltage V2 will be total 360. V1 will be 240. So this is V1 and this is V2. Now, as I told you already, current ratings should not violate. The same winding, 120 volt winding is here. That's why its current rating should be as it is 100 ampere. The current 100 ampere what is flowing should flow here in the same winding. That's why V2 I2 is the rating. Rating is V2 360 into 100 will give 36 kVA. For HV common additive polarity, we get 36 kVA. Output 360 volts. Let us check one more connection. Now this is HV, this is LV. So this connection is communicating you LV common additive polarity. This is 120 volt, this is 240 volt. So input 120, output is additive polarity 360. As per the question, both connections will give output 360. That's why I am showing both. But the difference is its capacity is 36 kVA. Its capacity will not be 36 kVA. What is its capacity? Same concept. V2 I2. What is the current rating? Current rating of this particular winding is 240 volt winding current rating is 50 ampere. So here we have to place 50. So 360 into 50 will give 18 kVA. Here rating is 18 kVA. See, both connections will give you 360 volt, 360 volt, load at 360 volt. But one is 36 kVA, other one is 18 kVA. This is a common confusion in this question. They gave both. 36 kVA given, 18 kVA given. Some students will take this connection because this will give 360. Some students may take this also. But here, what you have to do is you have to check what is the best connection in auto transformer reconnection mode. HV common additive polarity is always the best. The theory, that's what we see. So you have to give an answer for the best possible connection only. Both are giving 360 output voltage, but answer should be 36 kVA even though this connection is available. You should not take LV common because you know the best possible connection of auto transformer is HV common. If HV common is not given, then answer is 18, but as it is mentioned, go with 36. Next question, transformers. Core is wound with a coil carrying alternating current at a frequency 50 Hz. The hysteresis loop has an area 70,000 units. When the axes are drawn in units 10 power minus 4, as you know BH curve, full physics, for one cycle for one alternating cycle. This is how the BH curve can. In material science, you will see the total area of BH loop gives hysteresis loss. More precisely, hysteresis loss per one cycle. This is for one cycle. The area of hysteresis loop represents hysteresis loss. So, more precisely, it is hysteresis loss for one cycle per unit volume. This is a core concept here. So, first find out the total area given in terms of y-axis. B is taken 10 power minus 4 Weber per meter square Tesla. This is taken 10 power minus 4, this axis. X-axis is taken 10 power 2 ampere per meter. As you know, area, you have to multiply both. 70,000 units area is given. So, you know the total area is giving hysteresis loss per cycle per unit volume. Simply find out the total area with these units multiplied with the number of cycles multiplied with volume gives you finally hysteresis loss very simply. So, hysteresis loss, hysteresis loop area gives hysteresis loss per cycle per unit volume. So, if you multiply the total area into number of cycles into volume, you will get finally hysteresis loss in watts. So, let us do it here. 70,000 units multiplied with 10 power minus 4 into 10 square. This is hysteresis loss per cycle per unit volume. Multiply into number of cycles. What is mentioned? Frequency 50 hertz. So, into 50. Again, this is per unit volume. What is the total volume given? The core volume is 0.02 meter cube. By multiplying all, you will get a value 700 watts. The remaining part my colleague will take over. Thank you so much.
जा रहा हूँ अंदर।
Hello everybody, welcome back. This is Rajan Roy and we are going to discuss DC and synchronous part. Already you have transformer and induction. So the first question is related to the torque angle, basically load angle they are asking, but no problem, torque angle समझ लेते हैं, चलेगा. When the speed of motor is synchronous speed, right? तो सिंक्रोनस स्पीड पे अगर है, मशीन आराम से चल रहा है ना, ये देखिए, see here, सिंपल है. This diagram if you can remember I have taught you in class also. बस थोड़ा सा हम यहाँ मोटर को मान के चलेंगे, ठीक है. Same diagram I am, right? Suppose this is your field flux x, this is your armature, this angle is your torque angle, fine, क्या बोल दीजिए. And in motor, because in B part they have just written, see here, in 2 part the angle decreases in case of a motor. तो मोटर मान के हम लोग चलते हैं. तो in motor what happens, ahead of the rotor axis, right? That is why we take delta as. So now अब सोचिए at synchronous speed, what they are telling, the speed of rotor is synchronous speed, then the torque angle no change, even disturbance है but ns है तो no change, बात भी सही है क्यों. What is our equation, what we can write for motor is Te minus Tm is equal to I alpha, can remember, right? So now the point is, when synchronous speed is there, then alpha is 0. Alpha is 0 means there is a no change. So alpha is 0. Alpha is 0 means the speed will be same. Speed will be same means the gap between these two vector will be same, right? ठीक है जी, okay fine. अब सेकेंड पार्ट में बोल रहा है द एंगल डिक्रीजेज इन केस ऑफ ए मोटर इफ पी एस ग्रेटर देन पीई. तो मान लीजिए, और आगे बोल रहा है द मैकेनिकल आउटपुट इज मोर देन द इलेक्ट्रिकल इनपुट, यानी कि ये ज्यादा हो गया. अब सपोज दिस इज मोर, तो अल्फा क्या हो जाएगा, लेस देन 0. सर अल्फा लेस देन 0 यानी डी एक्सेलरेशन. डी एक्सेलरेशन मीन्स स्पीड क्या हो जाएगा, डिक्रीज हो, करेक्ट, कम हो जाएगा. When the speed decreases, correct, आप खुद सोचिए ये इधर जा रहा था और स्पीड कम हो गया, इसका स्लो हो गया, तो स्लो हो गया तो इनके बीच का गैप क्या होगा, बढ़ जाएगा. तो ये एंगल भी क्या होना चाहिए, बढ़ना चाहिए, राइट. लेकिन इसमें क्या दे रखा है, द एंगल डिक्रीजेस, राइट. तो वो क्या हो गया, फाइन. चलिए थर्ड पार्ट में आ जाते हैं. द एंगल इंक्रीजेस इफ द स्पीड मोर देन सिंक्रोनस स्पीड. सी इफ speed is more than synchronous speed and is greater than ns, it means how it will it happens, basically it happens when alpha is positive. alpha positive मतलब acceleration. तो खुद सोचिए अगर ये तेजी से आगे बढ़ने लग जाए मोर देन सिंक्रोनस स्पीड से, तो ये एंगल क्या होगा, डिक्रीज होगा. बट इधर क्या लिखा है, द एंगल इंक्रीजेस, ये भी क्या हो गया, राइट. तो वेरी सिंपल, आप मान लीजिए सपोज यू आर फिक्सिंग इट, तो इसको एक बार फिक्स कर दीजिए तो लेमडा इज नॉट चेंजिंग. एक बार तेज भगा दीजिए तो देखिए एंगल डिक्रीज हो रहा है बट इधर इंक्रीज बोल रहा है. एक बार स्लो कर दीजिए तो नाउ द एंगल इज इंक्रीजिंग बट इधर डिक्रीज लिखा हुआ. तो इट्स वेरी सिंपल, ये डायग्राम ड्रॉ करके इसका आंसर क्या हो जाना चाहिए, सी हो जाना. दैट्स फाइन, ओके. नाउ कम टू द नेक्स्ट पार्ट. व्हिच वन ऑफ द फॉलोइंग इज नॉट the remedy for reducing cross magnetizing effect of armature reaction. ये तो odd one odd भी कर दोगे तो चलेगा, that is by making the field circuit resistance more than critical. If field circuit resistance is more than critical value, so induced EMF 0, that was the necessity. Voltage built up condition we have studied, right? तो ये थोड़ा different discussion था, तो वैसे भी odd one odd कर दोगे जाएगा, because इसमें क्या बोला है, नॉट द रिमेडी. ठीक है, ओके फाइन. चलिए जी आगे बढ़ते हैं. नेक्स्ट, द टोटल आयरन लॉसेस इन द आर्मेचर ऑफ ए डीसी मशीन रनिंग एट दिस मच आरपीएम आर दिस. तो पावर दिया है, तो क्या पूछ रहा है, द अप्रोक्सीमेट ब्रेकिंग टॉर्क. तो टॉर्क क्या हो जाएगा, पावर बाय एन बाय फाइन. तो पावर कितना है, 1100 अपॉन बाय एन कितना है, 875 अपॉन हाउ मच इट, दिस इज इक्वल टू कितना आ रहा है, 12 ना. ठीक है, वेरी सिंपल, दैट फाइन, करेक्ट, सिंपल था. पावर इज इक्वल टू टॉर्क इनटू ओमेगा. नाउ कम टू थ्री फेज सिंक्रोनाइजर प्रोड्यूस एन ओपन सर्किट वोल्टेज. हाँ देखो, तो इधर सिंक्रोनस इंपीडेंस पूछा है, बट हियर दिस क्वेश्चन इज वेरी सिंपल बिकॉज it is not given the short circuit current is at which field current and all. One field current only given and voltage and current is given, correct. Even that is not mentioned where it is star connected, delta connected. तो सीधे आप whatever voltage is given divided by current कर दीजिए, जो भी आंसर मैच हो रहा है बस आंसर हो जाएगा. राइट, तो क्या हो जाएगा आंसर, बी आ रहा है ना. 8 point. That's fine. ठीक है. Okay. Now come to question number 21. Yes. हाइड्रोजन कूलिंग क्यों यूज करते हैं? क्लास में लिखा है, नोट्स में भी है, राइट? क्यों यूज करते हैं बताओ? लोअर डेंसिटी, हाँ जी सर, तो डेंसिटी लो होगी तो नॉइज भी कम, और हीट ट्रांसफर मोर, करेक्ट? ये दोनों चीजें बताया था. हीट कैपेसिटी ज्यादा होती है, दो रीजन दिया आपको, तो 1 and 2. वाइब्रेशन लॉसेस आर हायर, तो गलत, 2 गलत हो गया. 1 and 3, ये तो हायर तो नहीं, 1 and 3, करेक्ट? ओके फाइन. ये दोनों नोट्स में देखेंगे, ऑलरेडी आई हैव गिवन. ओके, नाउ कम टू द, हाँ, ये सिंपल जो फार्मूला बताया था, है ना, कॉइल पिच क्या था? कॉइल्स 10-1 डिवाइडेड बाय, कॉइल्स कहाँ से आएगा? इक्वल स्लॉट्स, डबल लेयर, तो कितने स्लॉट्स दे रखे हैं? 6. 60 +-1 डिवाइडेड बाय, इसके दो ऑप्शन आ, एक आ जाएंगे ऑलमोस्ट, सॉरी, T/2, तो कितने हो जाएंगे ये? 3, 17/3 और 3/3, राइट? तो अप्रॉक्सीमेटली ये 6 लेकर के प्रोग्रेसिव लेकर के RHS, ठीक है? तो क्या हो जाएगा? 6. फाइन. एक और लेंदी मेथड भी है इसका, बट दिस इज द सिंपलेस्ट वन. क्लास में भी यही फार्मूला मैंने आप, ठीक है? अब और कौन सा रहेगा? 75. सी, कंसीडर द फॉलोइंग स्टेटमेंट रिगार्डिंग स्पीड कंट्रोल ऑफ डीसी मोटर. डीसी मोटर के स्पीड कंट्रोल से रिलेटेड. इन फील्ड कंट्रोल मेथड स्पीड हायर देन द रेटेड स्पीड कैन नॉट बी ऑब्टेन्ड. बताइए, गलत बात है. कैसे नहीं ऑब्टेन कर सकते हैं? बिल्कुल कर सकते हैं, ठीक है? फॉर मोटर रिक्वायरिंग, मतलब ये ऑप्शन गलत हो गया ना, क्योंकि कर सकते हैं. फॉर मोटर रिक्वायरिंग ए वाइड रेंज ऑफ स्पीड कंट्रोल, फील्ड कंट्रोल मेथड लीड्स टू अनस्टेबल ऑपरेटिंग कंडीशंस फॉर पुअर. हाँ बिल्कुल, ये बात बिल्कुल ठीक है. क्यों? क्योंकि सी, इफ फील्ड इज वेरी लेस तो समटाइम्स स्पीड बिकम्स डेंजरसली हाई, तो इसीलिए वो लिखा हुआ है अनस्टेबल ऑपरेटिंग, करेक्ट, और पुअर कम्यूटेशन. फाइन, बिकॉज ऑफ एट लो फील्ड वेरी हाई स्पीड, ठीक है? द फील्ड कंट्रोल मेथड इज नॉट सूटेड टू एप्लीकेशन इन स्पीड रिवर्सल. हाँ, स्पीड रिवर्सल में या तो पोल चेंज या फिर उसके पोलरिटी को, मतलब पोलरिटी को चेंज करना पड़ेगा, बट पोलरिटी चेंज तो करेंगे नहीं, फील्ड को डिक्रीज या इंक्रीज करेंगे आप, तो दैट इज नॉट रिक्वायर्ड. E proportional to phi into IA, phi into IA, तो वी हैव टू चेंज द साइन ना. साइन के लिए क्या होगा? पोलरिटी चेंज करनी होगी, दैट इज डिफिकल्ट इन फील्ड कंट्रोल. तो इज नॉट सूटेड, तो करेक्ट हो गया बिल्कुल. तो आंसर क्या हो जाएगा? फाइन. अनस्टेबल ऑपरेटिंग कंडीशन हो जाता है, ये बात सच है, लो फील्ड पे बहुत डेंजरसली, और नॉट सूटेड ये भी, ठीक है? हो गया ना? तो क्वेश्चन का लेवल अगर देखा जाए तो मॉडरेट ही है, ज़्यादा टफ तो नहीं लगा मुझे, मशीन की बात करूँ तो, बट पिछले साल से थोड़े से टफर साइड में है. तो आई होप आपने जो होने वाले क्वेश्चन थे वो भी कर दिए होंगे, तो एक आध तो नहीं होते हैं, दैट्स फाइन, नो प्रॉब्लम. 90%, 80% भी कर दो, राइट? ऑल द बेस्ट.
Good evening, dear students. This time the total number of questions from electric circuits is 9. So I am going to now explain the solutions of electric circuits. The first question, so what is the power supplied by the each, the P1, P2 and P3 and P4? So P1 is equal to V into I. So P1 is the current is 5 amperes here. 5 amperes into 20 volts. P1 is equal to 20 into 5 is 100 watts, but it is delivering or not. So minus to plus, the voltage direction is minus to plus, the current also same direction. So delivering always represent as a minus. So इसलिए this is a minus 100 watts. Next P2 is equal to, P2 is 12 volts and the current is 5. 12 into 5 is equal to 60 watts. The 60 watts is observing. Voltage direction and current direction are opposite. So this element is observing the power. Next P3. P3 is equal to voltage into current 8 volts and 6 amperes. Here also same. The current is downward direction, voltage is upward direction. So 8 into 6 is equal to 48 watts is power observing. What about this dependent source? 0.2 I into the voltage. The voltage across this current source is 8 volts. The P4 is equal to 0.2 I into 8 volts. Where is the I? I is equal to 5 amperes. So 0.2 into 5 is 1. 1 into 8 is 8 watts. But it is not a plus. It is a delivering the power. Minus to plus. Voltage direction, current are both are same. So this is a minus 8 watts. So you just check it. Which option is correct? So D option is correct. Minus 100 watts, 60 watts, 48 watts and minus 8 watts. Option D is correct. Next is, what are the V0 and I respectively in the circuit below? Just apply KVL equation in this loop. I am writing now 12 minus 4 into I minus 2 V0 plus 4 minus 6I is equal to 0. Don't write a plus V0 पहले नहीं लिखना है. पहले according to your direction, current direction, entering is a plus, leaving is minus. So this is a 6 I0 I. What the V0 is replaced by? V0 is equal to now. According to current direction, here plus है इधर minus है, but a minus plus दिए. V0 is equal to minus 6 into I. In place of V0, just go to replace with the minus 6I plus 4 minus 6I is equal to 0. So 12 minus, how much this value is 12I, this is now 10I, this value is becomes 2I, here plus 4 is equal to 0. From this I is equal to minus 16 by 2, value is minus 8 amperes. Minus 8 amperes I, and what about V0? V0 is equal to minus 6 into I is minus 8. This value is 48 volts. So plus 48 volts and minus 8 amperes. The A is the option is correct. Okay. Next question number. The electron beam TV picture tube carries a 10 to the power of 5 electrons per second. Is given is a 10 to the power of 15 electrons. How to find the current? I is equal to Q by T. Q is equal to N into E by T, where N is the number of electrons into E is the electron charge. How much the value is 1.602 into 10 to the power of minus 19 coulombs.
Okay,
Upon 1 second. This is about current. They are asking about voltage. P is equal to V into I. Voltage into current. So from this, V is equal to P by I. Just substitute P is equal to 4 by this current I. You get a nearly equal to the value is 25 kilovolts. So D is the option. This case. Next question is consider the following statements regarding the network theorems. With independent sources, superposition theorem can be used only when the control functions are external to the network containing the sources, so that the controls are unchanged by the source act one at a time. Control switch, if your dependent sources are present in the network, don't disturb that sources. Remaining sources inactive कर सकते हैं independent sources को. This statement is correct. But second statement देखेंगे, a linear active resistor network which contains the one or more voltage or current sources can be replaced by single voltage source in series the resistance or by current source in parallel with the resistance. Thus the Thevenin's and Norton theorems are not Thevenin equivalent and Norton equivalent. Correct. Statement 2 is correct or not? And statement 3, the two resistors are same or not, in the both the cases RTH is same. So this also correct. But is the option में क्या है? 2 and 3. One option नहीं दिए, इसलिए 2 and 3 are correct. So option D is the correct. Above statement is are correct. So 2 and 3 are the correct options. So the remaining questions discussed by the Kiran sir. Come to the next
resistance value given 10 ohms. The data itself, current equation is given. Current equation is given. What is your requirement is the voltage. Voltage across the element as well as we need the power. We need the power. अब check करेंगे. देखो जी, corresponds example according to Ohm's law. Simply can I go like this here? V equal to I into R. That means we need the respective equation. V of t equal to I of t into respective resistance. For this particular example, what resistance value how much here? 10. What the current magnitude how much here? 2.5. Now if you multiply these two, what the voltage will be the 25. Voltage is 25. What do you reduce with it? Sin omega t. Okay, in the given options आप check किया तो which options we can eliminate here? This second is incorrect and third one is also incorrect. Now what is the one more requirement is the power. To get this instantaneous power equation, can I write this here? P of t equal to V of t into I of t, because in the option one more term given as a regarding power. If you substitute these two values here, V of t and I of t, what is the V of t magnitude how much here? 2.5. Sorry, V of t magnitude how much here? 2.5. What about the current magnitude is 2.5. Now 25 and 2.5. If you multiply these two, check kar lo ji, if you get approximately 62.5. Sin omega t, what we can write this way is sin square omega t. That means as per the given options, which one is correct here? First one. Okay. Come to the next one. Now for this particular example, what is your requirement is I think in the question what is asking the, I think he is asking the Thevenin's voltage as well as the Norton's current. For this particular example, as per the given options होना बोल तो आप check कर लो. Only by finding V Thevenin's value, we can conclude the answer easy way. Okay, let us see how can you find out V Thevenin's. This AB terminals are the open circuited. When it is open circuited, what the current of this branch equal to 0. That means voltage across the AB points, and this voltage both are the same. Voltage across this AB points and this voltage both are the same. With respect to ground potential, what is the polarity of this one is a plus. In this element no current is flowing, voltage across this element is equal to 0. Now plus similar polarity is subtraction. You can write this one as a by KCL. VTH minus 10 at an angle 0. What is the resistance value? How much here? 10. Now for this example, we can reduce the V Thevenin's by, what do you reduce with 3 plus J4. 3 plus J4 is equal to 0. चेक करो जी, आप रीअरेंज करके बोलिए आपका आंसर बोलिए. आप रीअरेंज किया तो एज पर गिवन ऑप्शन चेक करो जी, बोलिए जी आंसर बोलिए कितना है. एनीबॉडी? Anybody give the answer for this one? Give the answer for this one. Okay, check a look. Here the D is the correct option. I am not showing the options here. D is the correct option. Okay. देखो जी होना बोलते हैं शॉर्ट सर्किट करंट भी कैलकुलेट कर सकते हैं. शॉर्ट सर्किट करंट फाइंड आउट करने के लिए देयर आर टू अप्रोचेस आर देयर. वन इज होना बोलते फॉर एंटायर नेटवर्क के लिए फाइंड आउट द जेड थेवेनिन्स. बाय नोइंग द जेड थेवेनिन्स एंड वी थेवेनिन्स वी कैन फाइंड आउट द शॉर्ट सर्किट करंट. बिकॉज शॉर्ट सर्किट करंट इक्वल टू होना बोलते आप ऐसे लिख सकते हैं ISC is equal to VTH by ZTH. Otherwise, one more approach is simply AB terminals are the short circuited. Then after use either nodal analysis or mesh analysis. In that way, you can find out. But for this particular example, only based on VThevenin's value, directly you can see the answer. Ecology. Here the D is the correct option. Now for this particular example, what is the requirement is the Z parameters. To get the Z parameters, we have to take the help of the KVL equations. We have to take the help of the KVL equations. Now correspond input side. Correspond input side, if you write a KVL equation, lower potential to higher potential. What is source voltage? How much here? V1. Source voltage is V1. That what is the current of this one is a I1 current. What is the current of this one is a I2 current. For this example here, I1 current flowing the 3 and the 3. What is the total resistance? How much here? 6 I1. In this 3 ohm resistance, I1 is the downwards, I2 also downwards. Both are in same direction. Then what do you write the 3 I2? Can you compare this equation? Can you compare this standard equation? What is the standard equation? What do you write is with the V1 is equal to Z11 I1 plus Z12 I2. Chakaroji, if you compare these two, what is the Z11 equal to 6? Z11 equal to 6. What is the Z12? What is Z12 is equal to 3. Chakaroji, any options are eliminated? Second option is incorrect and third option also incorrect. And in the first option, last option, same answers are given. Now come to the other one more KVL equation. Concentrate on the loop 2. Concentrate on loop 2. Now by KVL for the loop 2. By KVL for the loop 2, lower potential to higher potential voltage rise. In this example here, higher potential to lower potential voltage drop. Again this in the 3 ohm resistance, I2 downwards, I1 also downwards, both are in same direction. At the 3 I1. What about this I2 flowing the 2 and the 3? 2 and 3. 2 and 3 means we can reduce to 5 I2. That means either simplify karne se we reduce as a 10 I1 plus 5 I2. Up can you compare the standard equation here? V2 equal to, we can reduce with Z21 I1 plus Z22 I2. Now if you compare these two here, Z21 and Z22 equal to 5. Chakroji, which option is satisfying here? The first one is the correct. First one is the correct statement. Okay. Option A, very good, very good, very good. In this particular example, we have to observe the given statements very carefully. Although slight changes are present in the given equations. Because the question mein what is asking regarding the charging or discharging? Is asking discharging. Discharging capacitor. Discharging capacitor ke liye what is the nature of voltage response? What is the nature of voltage response is the exponential decay. Discharging capacitor के लिए आप ग्राफ डेवलप किया तो nature of response is exponential decay. Exponential decay, if you come to the first one here, capacitor is a exponential decay. Yes, it is the correct. What the meaning of V0 is the initial voltage. What the meaning of this V0? V0 is the initial voltage, exponential decay. But if you come to the second one here, second one you give some E, but in the question we don't know what is the E value here. But actually that VR also we should write in terms of the V0 only. But given as the E, that's why we can say he is what is asking the not. That means it is not correct statement here. What about the one more thing is the discharging current. Discharging current के लिए आप graph develop current equation पूरा check किया तो we get the one magnitude is the same, but here what will happen here, the sign is the changes. Sign is the changes. During discharging what will happen, capacitor itself can behave as a source. it is delivering. The sign for the current changes, but here this is the plus. That's why here these two statements are the incorrect, because what you give statement is not discharging equation, Okay. Now for this one directly you can conclude here. Now again, what is the statement given as a for discharging voltage? Just now I concluded. For discharging capacity, what is the equation? What is the V naught exponential of, we write this way, minus T by tau. You can verify the each one here. Suppose if you substitute the T equal to 1 time constant. Suppose if you substitute T equal to 1 time constant. होना बोलता आप check कर लो. Check करने से we get like this here. Initially it reaches to 36.8% the initial value. That means here correspond to P, which one you are supporting here? 2. P is a 2. That means incorrect. That means no need to verify the last option. Directly you can say this is the correct. Okay. Okay, dear students.
Hello students, hi everyone. I hope you all done great. Okay, so here we are going to discuss computer fundamental question. First question, computer fundamental. Page fault occurs. Name itself page fault. What is page fault? Right? When the CPU executing the application according to one human error, CPU always refer in memory to access the program to execute. Okay, so if the program is not present in the main memory at the time of its execution, that is called as miss operation. So miss operation in the main memory. Page fault means required page is not available in the main memory. Okay, whatever the page looking for, that is not present in the main memory, called as the page fault. Okay, this is a straightforward definition. So go to the option, select that. So when a page currently not in a is accessed, so this is the direct answer. B is matching. Answer is B, because of it is a definition. Next question. Suppose that failure of two drives are independent. Two drives give disk drives. Drives matlab hard disk drive. They are independent. Failure of one is not connected to failure of another. Independent disks are there. One failure is not connected with another. So mean time between the fail, MTBF, time between the failures, they given 1 lakh hours, and mean time to repair is 10 hours. Then approximate mean time to data loss in a mirror system.
So this is actually RAID levels, redundant independent question. So this is also straightforward formula based. Here formula is like mean time to data loss, MTTDL. Mean time to data loss is approximately equal to mean time between phases, MTTF, mean time to failure on 2 into mean time to repair, MTTR. So equal to 1 lakh fair upon 2 into 10 hours. So total value is equal to 5 into 10 power 8 hours. But here question is asking in terms of years. Okay. Here mean time, approximate mean time to data loss of a mirror drive per year. So here value is hours. So hours to year calculation. So 1 year approximately equal to how many hours? 8760 hours. Therefore, MT mean time to data loss is in years is equal to 5 into 10 power 8 hours upon 8760 hours. Correct? So computational value is approximately 57000 is the answer. So it's like a formula based question, right? So when you see the options, correct answer is D. D is matching. Okay, student. This is the RAID level question, redundant array, dependent based. Next, right? Which of the following modifier tells the compiler that a variable value may be changed? Yes, okay, not explicitly specified by the program. Okay, so what it means? Variable value, for example, there is some variable. Okay, so this variable value will be changed. Value will be changed. For example, a is equal to 20. After some time it become 25. After some time it become 27. After some time 38. Like this. This value may be changed. Whatever the value is affected, change is affected with respect to the variable is called as the volatile. Volatile is nothing but a temporary. Okay, non-volatile memory concept is non-volatile. Volatile means temporary. Matlab, the volatile tells to the compiler stating that variable is not fixed with the same value. Okay, that variable may affected with different features due to function calls, due to some other registers. Okay, there may be a change in the variable data. That is the reason volatile is the correct matching. Volatile informs to the compiler that variable value may be changed. Okay, that is not a constant. So answer is A. Right. Next question. Consider the following characteristics of a CISC computer. Students, everyone knows the characteristics of a CISC machine. Okay, what are the characteristics? CISC contain less registers, more addressing. Okay, next is variable length in unsuccessful, EPI not equal to 1. Okay, general purpose, more instruction. Okay, uses used in the real general purpose application, that is personal, correct, less expensive, micro programmed control. These all are the different characteristics. So with that, suitable characteristics. First one, large number of instructions. Yes, more number of instructions, more addressing modes, also true. Instructions that manipulate operands in memory. Yes, because less registers. When we have less registers, instructions are accepting the data and manipulating the data, okay, directly in the memory, right? Fixed length instructions, no. So when you see the options, which is matching, 1, 2 and 3. So in this question answer, so already you know the characteristics of RISC and CPUs in our regular class, so you know directly. Next question, match the following list related to registers. Again, this is also explained in our regular class, okay. So processor register, what are the registers, mandatory registers in the computer, then what is its function, okay. So first thing, data register. Data register is nothing but a MBR or MDR. This data register is used to hold the main memory data. So data register is used to hold the main memory operand. Second, address register is nothing but a MAR. MAR register is used to hold the main memory address, holds the address of a main memory. Accumulator is a register used to hold the ALU input and output. So accumulator is a processor register, CPU register, default register. Then instruction register is used to hold the opcode. IR register is used for the opcode. Then program counter holds the address of a instruction, address of a next instruction, address of a instruction, that is. So matching check karo, P value belongs to 4, P belongs to 4, then Q belongs to 5, R belongs to 2, okay, S belongs to 1, P belongs to P4, Q5, R2, S1, A is the match. So in question, correct answer is A. Okay, students. Now, this is next question. Which one of the following types of instructions useful for initializing registers to assign a constant value? So this is addressing mode related question. When you want to design instruction, okay, where constants are directly implemented in the instruction, we use the immediate addressing. Okay, normally immediate addressing mode is used for immediate addressing, used to access the constant. Straightforward statement. Constants accessing के लिए immediate addressing mode is used. Okay, so this kind of question I explained in the regular notes as a instruction format. In the instruction formats, immediate field is given. In that immediate field, we are representing the constant, either unsigned constant or signed constant. Okay, so which addressing mode is used? There is immediate addressing is matched. Sorry. Okay, student. Next question. In operating system, which of the following approaches used to keep track of system activity, such as the number of calls made, number of operations performed to a network devices on a disk? Actually, this is the just question, conceptual question. Okay, in operating system, which of the approach is used to keep track of activities, system activity? Okay, system activities, system
इवेंट occurrences काउंट करने के लिए वी आर यूजिंग द काउंटर्स. डायरेक्टली स्ट्राइट फॉरवर्ड कॉन्सेप्ट. Counters used in the operating system which describes the or which keep track of the system activity. So straightforward answer is counter. A is also conceptual definition. Counter is used to track of a system activity. Okay students, that's all from the computer fund. Thank you.
Good evening, dear students. So myself Naresh Yalala, I am going to now explain the electrical and electronics measurements solutions this 2026 prelims examination में आए थे. These questions are now given. The first question is electrodynamometer type wattmeter में दिए. Here coil resistance, the current coil resistance is 0.1 ohm and pressure coil with a resistance of 6.5 kilo ohms. What is the percentage error while the meter is connected as a current coil to the load side में current coil connected है? So directly you can say P is equal to percentage error क्या है इधर इसमें percentage error is equal to I square into R by true power into 100 directly. If it is load side is pressure coil, then V square by R by PT into 100. I square is what the current is flowing here now already given. The current is 12 amperes and 250 volts. So 12 square into resistance of the current coil is 0.1 upon what a true power is, load power is the 12 V into I into cos pi. Cos pi is equal to unity power factor is given. So 12 into 250 into 100. You do this, you get a 0.48% directly. Option B is the correct. Next is second question. What is the expression for the deflection torque in a single phase induction type energy meter? Energy meter is highly inductive होना चाहिए. Why? Because the angle between here flux V and I must be, I magnetic flux will be in a pressure coil में प्रेशर वोल्टेज एंड करंट के बीच में फ्लक्स के बीच में 90 डिग्रीज होना चाहिए. दैट इज द बीटा इज इक्वल क्या होना चाहिए 90 डिग्रीज है तो इट विल गिव द एक्चुअल पावर मींस एग्जैक्ट पावर देते हैं. इसलिए टॉर्क इज प्रोपोर्शनल टू द इज आल्सो डिपेंड्स अपॉन फ्रीक्वेंसी. तो प्रेशर कॉइल फ्लक्स एंड आल्सो ए करंट कॉइल फ्लक्स ओमेगा बाय जेड sin बीटा cos अल्फा. ऑप्शन ए इज अ करेक्ट फॉर दिस क्वेश्चन. थर्ड क्वेश्चन, व्हेन सेकेंडरी वाइंडिंग ऑफ ए करंट ट्रांसफार्मर ऑलवेज पढ़ते हैं ओपन सर्किट करने के कारण क्या हो सकता है फ्लक्स डेंसिटी इन द कोर एंड पुशेस इट टुवर्ड्स द सैचुरेशन. सैचुरेशन के कारण हाई वोल्टेज विल बी इंड्यूस्ड ड्यू टू दैट दिस डैमेज द टोटल करंट ट्रांसफार्मर को डैमेज करते हैं. इसलिए ओपन सर्किट ना करना है. द पावर लॉस है नहीं है कि लीकेज फ्लक्स नहीं है. सो ऑप्शन ए इज द करेक्ट. The purpose of the start bit in a digital voltmeter is start bit क्यों होना चाहिए? start bit क्यों है? So the give zero indication के लिए start bit होना चाहिए. The option is here. Hold the digital volt in the display for a particular time. No. Provide the display of the information that comes from the A to D conversion. No. So that is the option is C is the correct for this start bit के लिए क्या है जीरो इंडिकेशन करने के लिए यू आर यूजिंग ए स्टार्ट बिट. And in general the range of digital multimeter
is generally 3 1/2 डिजिटल रहते हैं. 3 1/2 के लिए how many display or digits are now 4 digital displays रहते हैं. इसका 4 के लिए -1999 टू +1999 इसे जनरल में ये यूज करते हैं. सो इसलिए ऑप्शन डी इज द करेक्ट. ओके 3 1/2 डिस्प्ले यूज करते हैं. 3 1/2 में 4 डिजिटल रहते हैं, 4 डिजिट रहते हैं. सो 4 डिजिट्स में ये फुल डिजिट्स है, ये हाफ डिजिट है, 0 और 1 है. तो इसलिए रेंज क्या है -199 टू ये +199 तक डिस्प्ले करते हैं. नेक्स्ट क्वेश्चन नंबर 137. Consider the following statements regarding the power measurement by the 2 wattmeter method. तो 2 wattmeter method में W1 is equal to VLIL cos 30 plus pi or 30 minus pi and W2 is equal to VLIL cos 30 plus pi. Is about 2 wattmeter method. 2 wattmeters are connected in any two lines of the 3-phase 3-wire system will correctly indicate the total 3-phase power by the sum of, okay, P is equal to what now, W1 plus W2 or not. So the first statement is correct or not. Second is a meter will attempt to go down scale if the phase angle between the voltage and current exceeds 180 degrees है क्या? No. It is always if the power factor is angle is 60 degrees, that is a 0.5 k. Next is below, then is 60 degrees के ऊपर जाए तो that it is a negative में indicate करते हैं. So this second is incorrect. Third option is in practical case the balanced load is usually known to be inductive nature or not. Yes, inductive nature में रहते हैं. So is a balanced load. So third option is also correct. So which of the above statement is are correct? So 1 and 3 are the correct. So remaining questions discussed by the Raju sir.
Yeah, thank you, Naresh sir. Yeah, again is good. So good evening all. Measurements double E. Okay. The next question. Yeah. Okay. Okay. A single range laboratory type potentiometer has 18 step dial switch. Okay. It is there is a dial switch is available. Is your potentiometer. Okay. There is a dial switch is available. Terminal 1 and 3, terminal 2. How many steps are there? 18 step dial switch, where each step represents 0.1 volt. Each step represents 0.1 volt. So what is the maximum dial voltage? The Vmax or maximum dial voltage. Maximum dial voltage V dial is equal to, right, 18 step into 0.1 volt. Shall I write directly? 1.8 volts. Yeah, this is the maximum dial voltage. Next, the dial resistors 10 ohms each. The dial resistors
10 ohms each. The slide wire of a potentiometer circular, already I drawn, slide wire of a potentiometer is circular and has 11 turns, 11 turns, okay, and a resistance of 1 ohm per turn, right. What is the meaning of this one? इसका मतलब क्या है? 1 ohm per turn, 1 turn के लिए 1 ohm resistor, 11 turns के लिए how much? 1 turn के लिए, right, 1 ohm resistor, 11 turns के लिए how much? So obviously 11 ohms, okay, these are 11 ohms. Dial step how much? The dial step 0.1 volt, the dial step corresponds to 0.1 volt. This corresponds to how much? 10 ohms each, corresponds to 10 ohms each. Now, so dial step 0.1 volt corresponds to 10 ohms each. What is the potential gradient? The potential gradient, yeah, potential gradient is equal to 0.1 volt upon 10. How much? 0.01 volt per ohm, 0.01 volt per ohm. This is the potential gradient. इसमें क्या पूछ रहा है? The slide wire has 100 divisions, okay, good, and interpolation can be done to 1/4 of the division. What is the measuring range of the potentiometer? Okay, what is the measuring range of the potentiometer? What is the V slide max? The V slide max is equal to V slide max is equal. What is this one? 1 turn के लिए 1 ohm, 11 turns के लिए 11 ohms, 11 ohms into what is the potential gradient? 0.01 or simply 0.1 upon 10 ohms. How much you will get this voltage? This voltage is around 0.11. Yeah, this is 0.11 volt, okay, and maximum dial voltage 1.8 volts. So what is the total voltage? Tell me. V max is equal to, total voltage V max is equal to, right, V dial plus, okay, and V slide max, V slide max दोनों ऐड कर लो, 1.8 volts plus 0.11, right. Obviously this is 1.91 volts. It's a good simple question only, right. Only to understand the question is important here. Okay, next question. Yeah, it's a very good question. Consider the following statements regarding Maxwell's bridge. Maxwell's bridge is limited to measurement of low Q, correct. Actually Maxwell's bridge is used to measure low quality, Q less than 1, Q less than 1, low Q. Statement is correct. Actually in general some books they have mentioned that low to moderate, low Q to moderate, okay. The final balance equation of Maxwell's bridge are dependent on frequency? No. If you are going to observe in the next question itself only, they given the balanced equations, you can observe, even you don't know, in the next question itself Maxwell's bridge L1 equal to L2 into R3 by R4. Similarly unknown resistance R1 equal to R2 into R3 by R4. So if unknown resistance R1 is equal to, in a Maxwell's bridge the balanced equations R1 equal to R2 into R3 by R4, L1 equal to L2 into R3 by R4. Is there any frequency term present? There is no frequency term present. That is the reason in a Maxwell's bridge the balanced equations are independent of supply frequency, but here they given dependent. No, the wrong statement. Okay. Right. The balanced equation of Maxwell bridge is dependent of losses associated with the inductor. Suppose if L2 is having some losses, if L2 is impure inductor, whenever if it is impure inductor, definitely it has some losses, definitely it has some losses. So statement number 1 and 3 correct, okay. Hence option D is the correct answer. Question number 145. Next question. This is a very simple question. What they are asking, match the following, right. Maxwell inductance bridge. Maxwell inductance bridge just now only we told P is 3, L1 equal to L2 into R3 by R4. ACE bridge, right? In a ACE bridge, simply we can remember the balanced equations are highly dependent on supply frequency. In the given equations, the denominator term is presence of frequency. So ACE bridge L1 equal to R2 R3 C4 upon this 1 plus omega square R4 square C4 square. For high Q greater than 10, for high Q values, this overall the second term is neglected, then L1 equal to R2 R3 C4, right? Anderson bridge, the equation is this one, L1 equal to C into R3 by R4, right? Variable resistor, the small r is called variable resistor into R2 plus R4 plus R2 R4. In the regular class, usually after discussing of bridges, in the simplified way we given the shortcut, right? So it's a multiplication of variable resistor into addition of R2 and R4, then product of R2 and R4. Owen's bridge, L1 equal to R2 R3 C4. So hence answer option A is the correct answer. Yeah, next question number 147. The coil of a moving coil voltmeter 40 mm long and 30 mm wide. What is the meaning of this one? Area of cross section given. Area of cross section 40 mm by 30 mm. Convert into meters. 40 into 30 into 10 to the power of minus 6 meter square. Okay, this is important. Control spring torque is given. Control torque is given 240 into 10 to the power of minus 6 Newton meter. Okay, I think everything is given. Number of turns are given 100. Right? When a deflection is 100 divisions on full scale, okay, fine. If the flux density of the magnetic core 1 Weber per meter square, B also given, right? How many number of turns are given? Yeah, the resistance that must put in series with the coil to give 1 volt per division, to give 1 volt per division. Understand or not? So number of turns are also 100. B value 1 Weber per meter square. Directly substitute all these things. No need to write given date also. Okay, right. At steady state, usually deflecting torque is equal to controlling torque in a PMMC. What is the deflecting torque? Bina equation. Bina equal to controlling torque. Directly you can substitute. But related to this is voltmeter they are asking. So what is the resistance that must put in series with the coil to give 1 volt per division? This current I is equal to, directly I can write V by R. B into by R. What is this V? Full scale voltage into N into A. Directly substitute all these things. 1 is voltage 100 divisions. R I need to find. Number of turns 100. Area of cross section 40 into 10 to the power of minus 6 meter square. Control torque how much? 40 into 10 to the power of minus. I think this is cancel. 10 to the power of minus 6 cancel. Here 0, this also cancel. 4 3 is the 12. You can do the calculation. After doing calculation, the R value is around 100 into 100, right, into 10, right, or otherwise 2 ones are 2, here 50. 100 into 10, 50,000 or 50 into 10 cube ohms. So hence option B is the correct answer. Okay, right. Consider the following statement regarding moving iron instruments. Very good. Moving iron instruments have their deflection proportional to the square of the current. Yeah, theta directly proportional to I square. Absolutely correct. Okay. Moving iron instruments have uniform scale. Moving iron instruments have non-uniform scale because deflection theta directly proportional to I square. Obviously, this is non-uniform scale. It's not uniform. We can make uniform, but in general it is non-uniform. The wrong statement. Whatever the polarity, deflection theta directly proportional to I square. The instrument works for both AC and DC. Or deflecting torque directly proportional to I square. Instrument works for both AC and DC. Polarity is not a matter. It is also called, moving iron instrument is also called non-polarized instrument. Above the meter box of MI, if you observe, there is no plus minus symbol, simply terminal 1 and 1 dash. You can interchange also, no issue. So, statement number 193 absolutely correct. So, hence option D is the correct answer. Okay, next question. What is the equation for deflection of the pointer in an EDM, electrodynamometer type wattmeter? Yeah, particularly when you are dealing with AC supply, it is so good. In a EDM type wattmeter, the deflection theta is equal to, actually after doing the complete analysis or complete derivation, deflection theta is equal to I1 I2 cos phi upon Kc or K into dm by d theta. How you will get the deflecting torque is equal to, actually when you are dealing with AC supply, you must take average torque over a complete cycle, must take average torque over a complete cycle. Tau means torque, here 1 by t, t means time period, 1 by t integral of 0 to t. In general torque equation, I1 I2 into dm by d theta. What is this I1 I2? These are instantaneous currents. This I1 is nothing but IFC, fixed coil current. I2 is nothing but IMC, moving coil current. Both are right, both are instantaneous currents, both are instantaneous current. In general, I2 lags I1 by some angle phi. So, I1 equal to Im1 sin omega t, I2 equal to Im2 sin omega t minus phi. After doing this complete analysis, the final equation you are going to get deflection theta is equal to I1 I2 cos phi upon Kc into dm by theta. Hence, option A is the correct answer. Okay, this is question number 149. Yeah. Yeah, last question is a very good question. Consider the following statements regarding induction type instruments. Okay, actually this is related to induction type instruments or induction type energy meter only. Okay, if alpha will be 0, but instead of alpha, actually in the question they must give beta only, but they mentioned alpha. If alpha will be 0, the two fluxes, how you are saying sir beta, you may understand, you may ask the question. If two fluxes are in phase, then the net torque maximum, if on the other hand, if alpha is 90 degrees, the net torque is maximum for given values of phi 1 m and phi 2 m. Okay, what they are asking, which of the following statements are correct? Which of the following statements are correct? Okay, actually in energy meter, the torque equation, what is the torque equation? Phi 1 or otherwise phi sh, tent coil flux, series coil flux into sin of delta minus phi. Actually this must be beta, they mentioned in the question alpha. Okay, phi sh phi se. In general, how is it? Yeah, if I am taking supply voltage here, okay, VL or V phase, this phi sh flux lags the applied voltage. Phi sh flux lags the applied voltage by delta. If it is ideal condition, exactly 90 degrees, but it may not be possible, may not be possible. Okay, right. In general, the load current IL lags VL by phi. In real time practice, all loads are or maximum loads are 90% of the loads are inductive loads only. IL lags VL by phi. This IL is nothing but series coil flux only. Series coil is excited by load current. Tent coil is excited by supply voltage. Phi sh directly proportional to V phase. Tent coil is excited by supply voltage. Series coil is excited by load current. So, what is the angle between phi sh and phi se? This angle will become delta minus phi. Okay, delta minus phi. Now tell me, this is called beta. If the angle between phi sh and phi se, delta minus phi is maximum, suppose sin 90 is good, maximum torque you can get. Tell me, the net torque is in such a direction as to rotate the disc from the pole with lagging flux towards the pole with leading flux. It's correct statement. Okay. the expression for torque has a steady value all the times, obviously steady value all the times. Obviously the statement number 1 not be correct. Okay, if this is treated as beta sin 0 0, right, that is the reason here, hence option B is the correct answer. Okay, thank you.
Hello everyone, welcome to the video solution of Engineering Services 2026 Prelims exam for the electrical engineering. The question that we have taken is from the set B. Okay, so there were 3 questions that were asked. So the first question, very simple formula based question. The magnetic flux density on the surface of an iron face is 1.6 Tesla, which is a typical saturation level value for ferromagnetic material. What is the force density? Simple formula that we have to apply is F is equal to B square upon 2 mu naught. That's it, right? So B value is given, mu naught value is given, everything mu naught you know. So if you calculate it, you are going to get answer as B, right? So B is the correct answer for this. So 73 answer is B. Okay, next. Next question, L is measured value, question number 111. L is measured value of inductance with magnetic core. L naught is the measured value of the inductance without magnetic core. Mu naught is the magnetic permeability of free space. H is the height of the material under test. C is the outer diameter and the material under test. D is the inner diameter. Then what is the formula of the relative permeability mu r? Right. So basically this is basically forming a toroid. Fine. So we have internal diameter, outer diameter and some height. So toroid you can consider. So first of all, what you have to do, you have to find the magnetic field due to toroid, which is equal to, now number of turns is not given, so I will take 1. So I upon 2 pi r, r will be the mean radius, right? So from H you find B, from B you find flux, and from flux you have to find the inductance L, which will become your flux upon current I, right? Now here 2 things are there. One is measured with respect to magnetic core is the L. So that means if I take mu is equal to mu naught into mu r, so it will be for the L value, right? So this will give you the L value, and if you take mu is equal to mu naught, you are going to get the L naught value, right? So L value is known, L naught value is known, so you have to subtract it because your L minus L naught is there. So if you subtract it and solve it further, so in the complete solution in the website you will come to know. So here we are just discussing the answers. So when you solve it, L minus L naught, you will get the option B, right? So question number 111, option B is the correct answer. Now coming to the last question. The last question, consider the 141, consider the following statements regarding factors affecting capacitance, right? So that means we have to talk, we have discussing about the capacitance. The area of the plate is directly proportional to the charge, right? Now we know that Q is equal to C into V, or you can directly write it like this also. So they are asking the area is the plate is proportional to the charge, right? Now you know that what is charge, right? So charge, it will be equal to integration of rho s into ds, you can say. So this is equal to rho s integration of ds, this is equal to rho s into a, right? So it is saying that plate of directly proportional to the charge. So that means if you increase a, obviously charge storing capability will increase. So the area of the plate is directly proportional to the charge. The larger the plate area, the more electric charge. That is correct. So one statement is correct. Second, the longer the distance between the 2 plates, the stronger the produced electric field. Now we know that electric field is inversely proportional to D, right? So that means if you increase D, automatically electric field will decrease, right? So but it is saying that if the distance is larger, the stronger produced electric field. The statement is wrong. So 2 is wrong. Different insulating material will have different impacts on the capacitance. The dielectric constant is directly proportional to the capacitance. We know that C is equal to epsilon A upon D, right? So let us say this is epsilon naught into epsilon r A upon D. Fine. So charge is directly proportional to epsilon r. So that means if you change the value of epsilon r, Q will change. So what it is saying, the dielectric constant is directly proportional to the capacitance. That is correct. So 1 is correct and 3 is correct. That means answer is C. So answer for question number 141 is C.
Hello, my dear student. Very good evening. I am Jay Kumar. We shall discuss about microprocessor question. So there are a couple of questions which have been given by microprocessor from microprocessor this ESE 26. So coming to question number 52, match the following list. So there are some flags given, and we need to identify what is the correct option regarding this particular flags. Okay. So let us see what is the correct option. So here, if you know the flag register pattern, what is the flag register pattern? We have got sign, 0, auxiliary carry, parity and carry. So this is D0 bit, D1, 3, 4, 5, 7, D7 bit, right? There are 8 bits. Only 5 flags are there, these are unused, right? So now he is telling what is the bit position of this particular flags in the processor, okay? Right, the flag register, right? So auxiliary carry flag. So auxiliary carry flag is which position? It is 7, 6, 5, 4. Fourth position means P is 4. P is 4, D4 bit means third, P is 3. P is 3 is valid only for this option. Okay, blindly you can tell, but still you have to verify. Next one, parity flag. What is parity flag? Parity flag, second position, D2. So Q is 2. R, what is R? The next one, 0 flag. 0 flag is which position? 0 flag is R is 4 and S is 1. Carry flag is D0. So like this, the answer is option D. Very simple question. Look at the next question. Match the following list regarding interfacing 8155 memory section. So what is 8155? So 8155 is a multi-purpose IO device, a multi-purpose programmable IO device. The concept is a combination of 855, this timer 853. Okay, 8155 has got a concept of programmable ports. Okay, similarly it has got concept of a timer, and also apart from that, it has got a input memory also, some memory also, onboard memory with the chip, that is 256 bytes of memory is also there. So a RAM of 256 bytes and one timer of 14 bits, 14-bit timer is there, okay, and which can operate in 4 modes of operation. And similarly the concept of peripheral ports. So that there are 3 ports in this one, port A, port B and port C, where port C is 6 bits only, port A and port B are 8-bit ports. So these are some important features. So here it is a 40-pin IC. We look at the hardware section of this one, and here the IO device can be interfaced either as IO mapped IO or memory mapped IO. If it is IO mapped IO, the device will have only 8-bit address. If it is memory mapped IO, it will have 16-bit address when it is interfaced with the 8085 processor, right? So he is asking about the address lines. So for example, if you take these address lines A0 to A7, this A0 to A7 lines are bidirectional lines. They can be used for address and also for the data. So here these lines come to the first one, A11 to A15. So A11 to A15 means, for example, if I take A8 to A15, total 16 lines for the processor, when you interface with the 8155. So 8155 is 40 pin IC, 3 ports are there, okay. So 2 8s are 16 pins and 1 is 6, there itself it is 22. There are many other signals which are required, like read write signals, there are many other control signals, ALE signals and all. So therefore here some pins will be dual purposes, okay. So now if you observe here, the lines A8 to A15, these address lines are not separate lines, okay. So they will be something like whenever you have different registers. For example, timer is there, it's a 14-bit timer, there are 2 timer registers, lower byte of timer register, higher byte of timer register. That register also has some address, so therefore that address is selected by these lines also, A0 to A7. Therefore A0 to A7 are meant for register select. Similarly A11 to A15 may be used or may not be used. Sometimes they can be used, sometimes they need not be used, because it can be IO mapped IO or memory mapped IO. So therefore they belong to don't care condition. So the only left off is this one, that is chip select, because here the 9th pin is used for the this line. A9 can be used for the chip enable line. So this is how we can understand the combination. So you check which the correct option. So if you observe carefully, P1 is 1 and Q is 3, because this is 3 register select and this. So option B is the correct answer, okay. Key question. Look at the next question. Which one of the following code counters is used to remove the ambiguity during the change from one state of the counter to next during the state transition? If you look at the state transition, so what are the different counters? Gray code counter, BCD counter, XS3, binary. See, the name itself says gray code counter is the correct answer, because See, in BCD, what is BCD? Binary coded decimals. For example, 000 is the code for 0. 1 means 001, that is fine. Okay. If you go so on etc. to the next values, everyone need not have one change. So it may have different bit changes also sometimes. Okay. So it's not always one. So therefore, this BCD counter is wrong. XS3 code counter, the name itself is XS3 more 3, so it doesn't match. Binary code counter, that will also not match. And only left is gray code, because the very purpose of this counter is for reducing the ambiguity in state transition, because each value of this gray code will be modified by only one bit transition. So the confusion is less, ambiguity is less. That is the correct answer. 96A. Next one. Which one of the following gates is most commonly used in the design of a bus system? See, normal logic gates are OR gate, NOT gate, AND gate, and universal gates like you have NAND and NOR, and this is some XOR gate also. Okay. So here there is one more gate called as buffer gate. What is this actually? See, here to design a bus system, in bus means what? Group of wires or conductors used for communication between the processor and the IO devices. So here these buses like address bus, data bus and control bus, not every time all the lines are active. Depending on the operation, the control signals are generated. Okay. So therefore, what happens here is sometimes the buses must be switched off also. So whenever many devices are connected to the processor, for example, take 8085 microprocessor. So 8085 microprocessor lines, address lines can be connected to the memory. Let us say it is 64 KB of memory. It is assumed like this. Okay, and it can be less than that also. Similarly, these lines can also be connected to the IO devices. Understood? So therefore, whenever the processor buses are connected to more than one device, sometimes it has to send the data ones and zeros, sometimes it must be disconnected also. You cannot physically disconnect, so we use tri-state buffers. So this tri-state buffers are used such that the power handling capacity can be improved, or in other words, simple words is like to provide the isolation. This is one input line, output line and the enable line. This enable line is 0. Enable line is acting something like a switch here, right? So whenever the enable line is 0, then the buffer is in the active mode. In active mode there can be two states, either logic 0 state or logic 1 state. But whenever the enable line is 1, then this is something like so whenever it is 0 it is active, okay, so it's a low active enable line. Whenever it is 1 it is inactive. Therefore the switch is completely open, the current doesn't pass, therefore it is called as tri-state or high impedance state. So this is how the processor communicates with multiple devices with the same bus, depending on which device it is communicating to. Only that buffers will be active, remaining buffers will be inactive. So in the bus design system, buffer gate is generally used. So buffer gate is not a separate type of logic gate, it is the actual circuit symbol buffer gate. Okay. So in circuit design you can compare a CC configuration. So answer is D. Next one is, which one of the following is not operation perform a call subroutine instruction? The call instruction is used to call a subroutine in the main program. There is an instruction in 8085 called as call 16-bit address. It's a 5-byte instruction having 5 machine cycles and 18 clocks, right? So what is the purpose of call instruction? See, the purpose of call instruction is to call the subroutine within a main program. So for example, say this is the main program, and we need to go to some subroutine program. Okay, so this is the call instruction. Call is a 3-byte instruction. For example, say X is one address, I am calling some subroutine R1. R1 is present at some other address called as Y, and this is the subroutine. Okay, now fine. For example, once the program counter is at call, once the call instruction is fetched, call is a 3-byte instruction. So the next instruction is X plus 3 addresses. Okay, so some address plus 3. So the first step, whenever call is executed, the first step is the current value of program counter, means whatever is the next instruction to call, this instruction address is automatically pushed into the stack memory. That is the first step. The second step is, now the program counter will be updated with the new address of the subroutine. Then the program executes, and after the completion of program, return instruction will make this program control to come back to the main program again and continue from there. So based on these two sequence of events, the options are given. So you have to just check whichever is the correct option. So now what is he asking about? So is he asking about a correct one or not correct one? So observe the concept here. So he says that which option is not correct. Okay. Which option is not correct? So here the address of the next instruction available in the program counter is stored. That is correct answer only. Okay, correct answer only. Next one is correct answer. Next one is the control is transferred to the beginning of subroutine. That is also correct answer. And the third one is like he is talking about the written instruction. So written instruction is used to come back to the main program. That is also correct. Is also correct, but the D one is wrong. So he is asking which is not correct, right? Because the address of next instruction is stored into accumulator string. That is wrong, absolutely wrong. That is a false answer. So the next question answer is what? Option D. 101 is option D. Next one. Which of the following lines or diagrams are used when the data transfer is between an interface and IO device? See, for example, say there is some interface, let us say 8255 is there. Okay, 8255 can communicate, it has got 3 ports, can communicate with some input device and output device, for example say. So now 8255 has got different concept. This is interface with the processor 808, right? So the processor 8085 communicates with IO devices using the 8255. Now he is saying that between the interface and the input output device, what kind of communication is used? Whenever the input device is ready, it will send a strobe signal, and when the data is perfectly received, it will send one input buffer full signal. And whenever the data is available with this 8255, it will interrupt the processor on the pin called as INTR, interrupt request. This is also interrupt request. So these signals 1, 2 and 3, these are called as handshaking signals. So this is called as like authenticated communication between the devices and the interfaces and the processor. So these signals are called as handshake signals. See, for example, when you connect the pen drive, so there is a message which pops up. So my speed is this one, so and etc. So the computer will understand the speed of that pen drive and all. That is some OS which is already present inside to tell its features. In the same way, when the devices communicate between themselves and the processor, these signals are called as handshake signals, as handshake lines or handshake signals. Like it is authentication. For example, it has sent the data. It is authenticating that yes, I have received the data. Now it is informing that I have the data. Similarly, when the data from processor is sent to the device, then also some type of signals are required. Like it will send output buffer full, then it will acknowledgement this, again it will send one interrupt indicating to send the next byte of data transfer. So such type of signals are called as handshaking signals, right? So option should be B. The next one, in which one of the following data transfer schemes the CPU stays in a program loop until the IO unit indicates that it is ready for the data transfer while transferring data to and from the peripheral. See here it is in the program loop. See, for example, processor, if at all it is checking every device whether data is there or not, that is called as programmed IO. Is it clear? So, but in interrupt driven IO, the processor will not waste the time, because sometimes the IO device does not have the data, it should inquire everyone. So therefore what happens is the processor will be present in one infinite loop, okay, it will be executing some infinite loop. So whenever some device wants the service of the processor, it will interrupt it, so that the processor will not waste time in inquiring every device. So that is called as interrupt initiated IO, okay. So in programmed IO, the processor will waste lot of time. Is it clear? So DMA is for different, it is to transfer more data between memory and IO at a faster rate, that is different case using the DMA controller, okay, 8257 or 8237, and programmed interrupt IO. So this is not correct, it is called as interrupt driven or interrupt initiated IO. So option B should be the correct. So these are the different type of questions which were given. I hope you have answered well, and this time couple of questions are given, almost 7 to 8. Yeah. So may God bless you, all the best for your score in the
So welcome back. Let us discuss about the material science questions. So I will not be solving today, just giving you quick answers, because आप सभी tired होंगे तो बहुत ज़्यादा solve करने की इसकी ज़रूरत नहीं है detailed discussion की. So this question is saying what is the drift velocity of the electrons, knowing that this. So actually you see, you know that J, that is the current density, is NQ into VD, where Q is the magnitude of electron charge. So J upon NQ, and this J is given you current density, that is 10 to the power 7 ampere per meter square. N is given you 10 to the power 28 number of electrons per meter cube, and Q you know 1.6 into 10 raised power minus 19. So when you solve this, you get 6.24 into 10 raised power minus 3, that is given in option D. So right choice for this question is given by option D. Next question. Which one of the following is generated by the supplementary precision movement of the conduction electrons that appear when? देखो conduction electrons की वजह से जो magnetism मिलता है, diamagnetism, that is known as Landau diamagnetism. So B आएगा, and Langevin जो होता है, that is because of the bound electrons, and this is because of the classical theory where the orbital motion is disturbed. So the B is the right choice for this question, option B. Next. The cermet AuSi is obtained by. So cermet is what? Metal के particles को you reinforce into the ceramic material. So accordingly you choose the option. So the deposition on glass support. SiO2 is what? Glass support and consist in conductive particles of the gold speeded in amorphous matrix of SiO2. So option A is right choice. Here in cermet what you do? You take the matrix of the ceramic. Ceramic is what? SiO2, that is glass, and you insert the particles of the conductive material. Here the conductive material is gold. That is the meaning. Only English they are trying. Here you have to memorize this question 109 जो है इसको memorize करना पड़ेगा अगर किसी को याद है तो. These are the class of insulators and उनके maximum operating temperature. So D option is the right choice for this question 4123. So for this question your answer should be D. Next you go match the list following this 109 is done. Now 112. He's saying consider the following statements regarding ferrites. So ferrites are linear material. यही गलत हो गया. Ferrites hysteresis show करते हैं और if they show hysteresis then they are non-linear material. So option 1 is wrong. आपसे पूछा which of the following are correct. So 1 wrong, ये correct नहीं हो सकता है. Then he's saying the balance the values of saturation inductance and remanent inductance are lower. Yes, because this retentivity and coercivity are small. Then you have what? Which of them are correct? So it is correct. 2 is correct. Magnetic permeability is lower. No. You see, since it is a soft magnetic material, for soft magnetic material, slope dm upon dh is high, and if slope is high, then magnetic permeability and susceptibility is high. So 3 is wrong, 1 is wrong, only 2 is correct, and that is the given by option B. ऑप्शन बी सही है. नेक्स्ट आते हैं अगले क्वेश्चन पर. अगला क्वेश्चन है व्हाट इज द कंडक्टिविटी ऑफ कॉपर एट 300 केल्विन इफ द कोलिजन टाइम. यहां जो आपको फार्मूला लगाना होगा दैट इज NQ स्क्वायर टाउ C अपॉन मास. सो दीज वैल्यूज आर गिवन टू यू. N is given to you if the collision time tau for the electron is this, collision time is given and number of electrons is given. So that is 8.5 into 10 to the power 28 into Q का square 1.6 into 10 raised power minus 19 का square into tau C. Tau C is what? Tau C is 2 into 10 raised power minus 14 and divided by mass 9.1 into 10 raised power minus 31. When you solve this value you get 4.8 into 10 to the power 7 which is given in option A. So right choice for this question is given by option A. इस क्वेश्चन के लिए जो सही आंसर होगा वो ऑप्शन ए होगा. नेक्स्ट आते हैं मटेरियल साइंस का. ये अब देखो इस क्वेश्चन में वैल्यू रटने की जरूरत नहीं है. आपसे क्या पूछा है? लिस्ट मैच करना है एंड डेंसिटी. एल्युमिनियम को हम ट्रांसमिशन लाइंस में यूज करते हैं. क्यों? बिकॉज इसकी डेंसिटी लो होती है. सो एल्युमिनियम हैज लोवेस्ट डेंसिटी. इस कंसेप्ट का यूज करिए, आपको ये आंसर बड़ी आसानी से मिल जाएगा. सो एल्युमिनियम इसमें सबसे कम डेंसिटी वाला कौन सा है? 2.7. सो एस शुड बी 1. S1 सिर्फ एक ही ऑप्शन में है, दैट इज ऑप्शन सी. सो राइट चॉइस इज सी. बाकी आप सबकी डेंसिटी देख करके मैच कर सकते हैं, गूगल से कर सकते हैं, बट इसमें वैल्यू रटने की जरूरत नहीं थी. एल्युमिनियम लाइट वेट होता है, हम सभी तभी फॉइल ऑयल भी इसकी यूज करते हैं, तमाम सारे काम करते हैं. देन ये क्वेश्चन ये मैथेसन्स रूल पर है. एलॉय की जो रेजिस्टिविटी होती है दैट इज रेसिडुअल रेसिस्टिविटी एंड प्लस एलॉइंग एलिमेंट के कारण मान सकते हैं या थर्मल कंपोनेंट इसका मान सकते हैं. सो यू कैन राइट लाइक दिस. इसको ऐसे भी मान सकते हैं मैथेसन्स रूल से कि जो मेटल के कारण कंपोनेंट है प्लस जो एलॉइंग एलिमेंट के कारण कंपोनेंट है. यू कैन मॉडिफाइड लाइक दिस. ठीक है, मैथमेटिक्स मेटल वाला पार्ट आपको दिया हुआ है, ठीक है, एंड ये मेटल का आपके पास ये है, ठीक है, एंड टोटल ये दिया हुआ है, यहां से 4% के लिए रो एलॉय आ जाएगा। तो जब आप 4% के लिए या रो इम्प्योरिटी कह लो, एलॉय नहीं, एलॉय तो टोटल है, सो दिस वुड बी बेटर टू राइट इट इम्प्योरिटी के कारण, ठीक, मेटल एंड प्लस इम्प्योरिटी के कारण। सो जब आप इम्प्योरिटी के कारण कैलकुलेट करोगे तो 4% के लिए दिस वैल्यू विल कम आउट 5.8 into 10 raised power -8। कुछ नहीं करना है, इसमें से इसको सब्ट्रैक्ट कर दो, दैट इज 5.2 into -8। अब ये कितने के लिए है? 4% के लिए। तो 1% के लिए कितना हो जाएगा? इसको डिवाइड बाई 4 कर दो, इसको डिवाइड बाई 4 कर दोगे तो 1.3 into 10 to the power -8 आ जाएगा, दैट इज ऑप्शन डी। सो राइट चॉइस इसके लिए ऑप्शन डी हो जाएगी। ठीक है, सिंपल क्वेश्चन। नेक्स्ट आते हैं। Next is question number 134. Consider the following statement regarding atomic bonds. अब इसमें बहुत सारी कहानी है, एक पॉइंट मैं पकड़ूंगा। If the atom or molecule has completely filled outer cell. Completely filled outer cell का मतलब क्या हुआ? Completely filled outer cell का मतलब inert gases. Inert gases में कौन सी बॉन्डिंग होती है? वैन डर वाल। प्राइमरी बॉन्डिंग नहीं होती है। ये बात हम लोगों ने क्लास में डिस्कस भी किया है। तो विल बी अ प्राइमरी बॉन्ड, ये बात गलत है। तो स्टेटमेंट 3 गलत है, स्टेटमेंट 3 गलत हुआ, ये दो ऑप्शन चले गए। ठीक, अब आगे देखते हैं। विद द इंक्रीज इन डिफरेंस ऑफ द आयनाइजेशन पोटेंशियल द बॉन्ड विल बी फॉर्म विल बी मोर आयनिक। जी हाँ, इलेक्ट्रोनेगेटिविटी का डिफरेंस जितना ज्यादा होगा बॉन्ड उतना आयनिक होगा। इफ द टू आयंस विद द सेम आयनाइजेशन पोटेंशियल फॉर्म अ बॉन्ड देन दिस बॉन्ड इज प्रोबेबली आयनिक। नो, सेम आयनाइजेशन पोटेंशियल वाले कभी आयनिक बना ही नहीं सकते। सेम आयनाइजेशन पोटेंशियल वाले क्या बनाएंगे? या तो मेटालिक बनाएंगे या कोवैलेंट बनाएंगे। आयनिक होने के लिए दोनों में आयनाइजेशन पोटेंशियल का डिफरेंस होना जरूरी है। याद हो तो क्लास में मैं लिखाता हूं ग्रेटर देन 2 होना चाहिए। So this is also incorrect. So 1 and 3 are incorrect and the correct option is 2. So answer is given by option B. So B is the right choice for this question. Next चलते हैं। अगेन इसमें आपको मैच करना है, फिर से वैल्यू रटने की जरूरत नहीं है। सिल्वर इज द बेस्ट इलेक्ट्रिकल कंडक्टर। सो सबसे कम सबसे ज्यादा इलेक्ट्रिकल कंडक्टिविटी सिल्वर की, यानी सबसे कम रजिस्टिविटी किसकी होगी? सिल्वर की। सो मिनिमम रजिस्टिविटी वाला इसमें कौन सा? सारे 10⁻⁸ में है। सो सबसे छोटी वैल्यू कितनी है? 1.4। ये किसके साथ मैच करनी चाहिए? सिल्वर के साथ। तो S का 4, इन दोनों में से कोई हो सकता है। अब सिल्वर के बाद लिथियम, सोडियम, पोटेशियम और कॉपर, इनमें क्या मिलेगा? कॉपर। कॉपर इज बेटर कंडक्टर, दैट्स व्हाई वी यूज इन इलेक्ट्रिकल इंडस्ट्री। हालांकि गोल्ड होता तो सिल्वर के बाद गोल्ड लेते, लेकिन गोल्ड नहीं है। ये सब मैंने क्लास में ऑर्डर लिखाए हैं, वैल्यूज नहीं। तो कॉपर का लीजिए, तो R का 1.47 के बाद यानी 1.56। सो R का 2 इज अब कौन सा ऑप्शन हो जाएगा? C। सो राइट चॉइस इज C। बाकी दोनों का देखने की भी जरूरत नहीं है। सो 135 का आंसर हो जाएगा आपके पास C। ठीक, सो दीज वर द क्वेश्चंस ऑफ मटेरियल साइंस। बेसिक क्वेश्चन आए हुए थे, थोड़ा सा आपको लॉजिक लगाना था, दिमाग लगाना था, तो आप सारे क्वेश्चन निकाल सकते थे। देयर वाज नो वेरी डिफिकल्ट क्वेश्चंस। थैंक यू, दैट्स ऑल फ्रॉम माय साइड। थैंक्स अ लॉट।